the NCBT conference. Today's program promises to be just stimulating with insightful presentation, engaging discussion, and plenty of opportunity to connect with the colleagues. This conference promises to be fascinating exploration of the latest advancement in microbiology. We'll hear from leading experts, engage in the stimulating discussion, and foster the new collaborations. Today we have an opportunity to learn from the experts, explore into cutting-edge discoveries, and inspire by the new possibilities under the Web of Microbiologists Association. This Web of Microbiologists Association originated in the initiate on the occasion of superannuation of Professor Satya P. Singh at Saurashtra University in October 2020. The Web of Microbiologists emerged as an online network initiating a diverse community of microbiologists in Gujarat, driven by a passion for collaboration, motivation, and the growth. The Web of Microbiologists aim to create the bridge and build a network among the retired, senior, and junior faculty members and the students. This WOM, Web of Microbiologists event, serves as a vital platform for us. It creates a building bridges, strong networks to facilitate the knowledge exchange, mentorship, and career guidance for aspiring microbiologists. It also serves for initiating excellence, engaging communities, and foster the collaboration by connecting with the colleagues from the diverse background. We can spark innovative ideas and build a network that will propel our field forward. WM started in 2020, but after the pandemic, it could not be continued for this year. Due to this reason, the 3-year was the break, and now we are organizing this WOM organization in 2024. Today we have a Professor S.P. Singh as a guest faculty and supervisor as former UGC DSI faculty and Professor and Head of Department of Bioscience, Saurashtra University, Rajkot. Let me introduce Professor S.P. Singh, sir. Currently he is working as a guest faculty in Saurashtra University. Previously he was a Professor and Head, Associate Professor, and he has completed his PhD in the Griffith University, Australia, MPhil from the JNU Delhi, MSc from the GB Pant University. He is also visiting professor in the Japan and the University of the Myanmar. He has more than 38 years of the experience. His research area, major research area is diversity, physiology and biocatalytic potentials of the halophilic and haloalkalophilic bacteria, hyperthermophilic bacteria, protein engineering, structure and function relationship. He has completed supervision of the more than 25 students of the PhD, 24 students of the MPhil, and more than 115 students of the dissertations. He has more than 110 publications in the various reputed journals. He has completed many of the research project granted from the DBT, MOES, UGC, GSBTM, ISAR, and he has many collaborative research with the other international university also. So today we have such kind of the expert with us. I request Dr. Professor Satya P. Singh for give his insight in the same. I welcome sir. Sir is going to give his speech online.
Sir, please unmute yourself.
Am I audible? Now it's unmuted. Is it okay?
Yes, sir, you are audible.
Can you hear me?
It's my immense pleasure to welcome my mentor on this online platform. Due to some unavoidable circumstances, he is not here with us, but he is going to deliver the speech online. Welcome, sir.
Thank you very much. Thank you. So I'm going to share my presentation.
Sir, full screen कर दीजिए sir.
Is my screen visible?
Yes sir, but it is not full screen sir. Full screen कर दीजिए.
Okay, just a minute. Okay. Now, Rajesh?
Yeah, now it is working sir. Just to change one or two slides so we can get sure that it is getting changed also.
Okay. Is it moving?
Yeah, it's moving sir. Fine. Fine sir, you can start. No problem.
Okay. And shall I increase the volume or is it okay?
Now volume is also okay,
Rajesh?
sir. We have joined with the amplifier so we can manage
Okay.
at our place. There is no problem. You can just have the
Okay,
full screen
okay.
option.
Okay, thank you. Good morning, everyone. As it was just said by Madam, the introduction, this initiative was taken 3 years ago, and I am happy that Professor Rajesh Patel has taken this initiative to resume the activity which was upheld due to the COVID pandemic. So thank you, Rajesh, for this efforts, you and your team, and for integrating this event into your major national conference. That's very nice. And I can see only few people have joined online, but I hope that there are some people offline. What is the status, Rajesh? There are people have joined online or offline? Hello?
Sir, we are projecting in the hall only, so all other people are offline only. You can also see.
Okay, okay.
So your presentation
Yes,
is on
sir,
screen
yes.
only. Your presentation is on screen.
Okay, okay, okay. The time that I've been allotted about 15 minutes, so I will speak not a structured or very related subject of microorganisms from extreme environment, but a general aspect. Some of these aspects relate to the dimensions, new dimensions in microbiology during the last 25 years or 30 years. Now, what are the recent trends actually? We can see that if you compare 25 years ago or 30 years ago and now, today it's a time of multidisciplinary approach. The conventional boundaries have dissipated actually, the botany, zoology, and because that is the need of the time. What are the advantages? Because if you are going for multidisciplinary approaches, then you are able to generate new knowledge, which otherwise you are not able to. Then to answer basic questions related to life and nature and their interactions, and the search for new potential, and unconventional thinking. For example, if a physics person, if a physicist thinks about biology, then his or her questions may surprise you. But initially it may sound very strange, but that may generate a very revolutionary idea. And the history is evident that many of the researchers in life science and biological sciences, they have been carried out by those who are not traditionally trained in biological sciences, in not biology. They were from physics, they were from chemistry. Many examples in our journey. Now, why microbes from extreme environments are important? They are important to us because of many reasons. Some of them, they are more, because they are evolutionary relics. Because they are evolutionary relics, and they are important to us with respect to evolution of life, because the conditions they live in, they are very hostile, and that's why they have many secrets in them regarding the origin of life, the functioning of the life, and adaptations. That's why there are evolutionary relics, and that's why a lot of emphasis is being laid on them. I'm not going to elaborate this aspect any further on this, but just the relevance that this is one of the major differences that people are paying so much attention to this. Why? Because of the climate change, because environmental is getting hostile. And when you're talking about hostility of the environment, then you need to talk about these microbes. Now, thinking of the progression. We all are aware, many of us are teachers, maybe at our early stage. We started with whole organisms, then tissues, cells, organelles, mitochondria and chloroplast to be particularly. Then we came to molecular arena, and the beginning was with single gene or single protein. And mostly that was related to commercial aspects, cloning of a particular gene and for the commercial purpose. Then cloning and expression, but that did not answer many questions at cellular level. The biology will not be advantages as such. For that, we need to address the multiple genes and multiple proteins. So that then came the era of genomics and proteomics, and now we are in the era of metagenomics and biomes. Now, comparing our status with the rest of the world, particularly the Western countries, US, Canada, North America, and Europe, we have been lagging. If we just take the example of 70 years, so just a sketch of the comparison, not very in rigid terms, of course. If you compare 60s, 70s, when they were working on biochemical aspects, we were working on organisms, cultural aspects, growth behavior, and things like that, carbon and natural resources. Then came next era. When they started working on molecular aspects, for example, cloning and expression, we came to biochemistry, enzymes, kinetics, and metabolism. Then came 2000. Then when they started genomics, proteomics, and structural biology, we entered into the cloning and expression, but single gene at a time. Now, this is the era of metagenomics and microbiome, and we are catching up very fast. So we are at par with the global scenario. Now, the point that I would like to emphasize here further is the debate between cellular science and sequence-based science. For example, cellular, biochemistry, structural biology, and sequence-based. You have a sequence and you can do a lot of analysis bioinformatics. So, for example, these are some examples. Metagenomics versus cultivation. In the era of metagenomics, cultivation is still important. In the era of structured genomics, because no matter how much structured genomics you are going to do, unless you go to functional aspect, then it will not be very worthwhile. So simply going for whole genome sequencing, structured genomics, unless you go for functional aspects, okay, then it will not be meaningful and purposeful. So that's, and further, the sequence-based analysis must be validated on cellular level. Cellular validity is very important. And huge, in today's time, huge volumes of sequences are being generated globally, and we need very powerful computational abilities. We need data science, a new dimension, a new science in its own right has come up, data science, because it's very difficult to draw any inferences, draw any conclusions. You have a huge volume of data, but what to do with that data? Unless you are able to generate or draw any. So that is the question. So at times you feel that there is a lopsided development. Many of us are working on sequence-based science, but unless we relate this to cellular biology, the metabolism, physiology, gene expression, that is functionality of the genome, then it is incomplete. So that's why there is a need for integration of sequence-based analysis and cell biology. And I don't mean to say that they are mutually non-exclusive. These two approaches are mutually exclusive. Rather, this is the requirement. This is the need. They are complementary. The sequence-based science and the cell-based science. There is a need for integration, rather complementation. Okay, they are not mutually exclusive. Now, very recently, I came across with this paper just a few weeks ago, which says that biology is not genetics, is not entirely genetics. Of course, we are taught to believe that genes are blueprint of life. True, there's no debate about it. But are genes functioning on their own? They are controlled by their own? No. The genes are governed and regulated by myriads of cellular, physiological, and environmental factors. So genes are the blueprint of life. No doubt about it, no debate about it. But physiology remains important. The other aspects of biology remains important because the regulation of gene expression, interaction of the regulations of many genes, it is governed by many factors beyond the sequences, beyond the structural genomics. That's why I believe that biology is not entirely the genetics. You may like to read this. I think I found it very interesting just a few weeks ago. Another thing which is important, that a lot of emphasis is being laid on the climate change, the extremity of the environment. But in this scenario, the role of microorganism is being undermined. Microorganisms, they play a most important role in extremity or under stressful conditions. But when you talk about the climate change, hardly there is any mention. Hardly there is a talk on their role. They play so much important role. They are the major driver of the elemental cycle. They are the first barrier. They are the first barrier of any extremity. They are the producer as well as consumer of the greenhouse gases. So they are the targets as well as they are the solutions of these extreme conditions or climate change. That's why they should be paid attention with this particular aspect. Now, the another aspect related to is the disruptive science and incremental science. Now, this paper is published about a year ago, I think, in Nature. And what does it say? They have analyzed a large number of research papers over from 1945 to 2010, a large number of research papers, and they found that disruptive science is declining. What is the disruptive means? You are challenging the pre-existing knowledge. You are raising questions against what is prevalently accepted. So unless you raise questions, unless you raise doubts, new knowledge will not be generated. Most of the research is the incremental research. you are adding something to the already existing knowledge. Okay, so the disruptive science is decreasing, and that is a scientific study based on the papers published in 1945 to 2010. This is very interesting. I think human and this aspect is corroborated by another novel or Sidney Brenner. The next slide, you see there's Sidney Brenner. Biology must generate ideas, must generate knowledge, because generating data itself is not objective. Generating data is a means, is a pathway to reach to a conclusion, to generate knowledge, not end of it in itself. So generating data is not the end of it. So it's just a way, it's a path, it's a means to reach to a conclusion, to reach to a decision that, yes, this is the concept, this is the theory, this is the thing. We are drowning in ocean of the data, but is starving for the knowledge. So that's the observation by Sidney Brenner, as well as many other scientists, that while we are generating huge data, in that ratio, the knowledge is not being generated. And I always in my presentations, I always quote this by Richard Philip Feynman, who is a theoretical physicist, a Nobel laureate. And I believe, and I think many of us, we are teachers, maybe in your early stage of your career, that what is the purpose of the higher education? Purpose of higher education is not merely the accumulation of certain informations. Now, accumulation of information is much easier nowadays. No, anybody can do it. The purpose of higher education is to train the mind to think, to ask questions, and to identify the mistakes. Unless we do that, new knowledge will not be generated. And that's why the importance of learning. The Feynman again says that it is the learning which is important. Learning at any stage. Teachers, if teachers stop thinking that we don't need to learn, then that is end of it. That should not happen. Learning is a continuous process. Learning, so you keep on learning, and then you will reach to some stage where you will learn something which nobody has learned so far. I always acknowledge my colleagues, my research team, and those who are associated with me for the last 30 years at many levels, the masters, PhD, some of them postdoctoral, 30 years, and many of them you're very much aware about them. Some of them I have highlighted here, and total 25 PhD students have completed their work. 2 more PhD students are working, so 25 PhD students plus 2 more, 23 MPhil students, more than 115 MSc students, and still 2 PhD MSc students are still working. So I am grateful to Department of Bioscience and Saurashtra University for giving me this opportunity to continue my research and continue to get involved in teaching and research at Saurashtra University. So I very clearly I acknowledge the contributions of those who are associated with me, and still directly or indirectly, most of them, they are still associated either directly or indirectly. But what is most important thing, and what gives you most intense pleasure, that most of them, they are settled, they are doing so well, and they are doing independently, and they have established themselves in their own right. There are many examples, as you can see from this list. Nothing can give you more pleasure than this. Those who are interested in our work may please visit to the scientific platforms, so which gives an idea about what we have been doing and what has been our journey. So I thank you once again Professor Rajesh Patel and your team for integrating this event into your main conference event. There has been a lag of 3 years, of course, due to unavoidable circumstances. And I congratulate to those who are judged, whose papers are judged as the best papers. I congratulate to them. But more importantly, I congratulate to all of you who entered into this, and large number of entries we received, and the one and I thank you very much for this, that because of the large number of entries we are able to decide only on the research papers. The decision on the thesis will be taken after some time, because the committee felt that we need some more time. So maybe for best PhD thesis in coming weeks. I'm grateful to the members of the committee who spent so much time to decide about the best papers, and they are doing for the best thesis as well. So once again, thank you very much. Thank you very much for giving me this opportunity to speak to you. I'll be happy to hear from you if the time allows, from you, your opinion on the aspects that I highlighted. Thank you very much. Madam, if there is any time, and anybody would like to ask any questions, if there is any time from your audience, can you spend some few minutes? Questions, opinion, or queries, uh, or you may interact me later on at some other time. But I'd be happy. And regarding the web of microbiologist, I would be happy to hear from each one of you, students, faculty members, seniors, about the ways we can make it more effective in future. We would be very happy to hear about. Yeah, sure. Thank you. Thank you very much. Thank you very much for this opportunity. I wish you all success. And this conference has been very effective and and this event was integrated into your major conference. Thank you all very much. Thank you.
Presentation of today's event of Web of Microbiologists. We have eminent speaker Dr. David, Department of Microbiology, University of Ilorin, Nigeria. I request Dr. Jagruti Barot to welcome Dr. David. Please, sir. Let me introduce Dr. David. He has distinguished experience in the various fields of the academic. He obtained academic credentials from the University of the Ilorin, Nigeria. He got the Fulbright program scholarship as a visiting scholar in Oklahoma University, USA. He got also award of Ilorina Staff Development, and he has more than 42 peer-reviewed journal publications. He is actively engaging in various different kinds of the training and program in his university. He secured several research grants from the African University, and he is the chairman of the United States Government Exchange Alumni Association of the Nigeria. So we have an eminent speaker with us. Welcome you on this event, sir. I request you to continue with your speech.
Thank you. Can I use this? Can I use it? Okay. Do you have my PowerPoint? I sent it by WhatsApp. Will I be able to see it? Will I be able to see it here?
No, you can see.
I will see it here. If I can't see it here, I will use.
Yeah, you can directly change the slide from this one.
Okay.
Forward and
Okay, forward and backward. Use the pointer.
this is pointer. Well,
Oh, thank you.
yeah, you can try to change whether it's
All right.
not. It's okay.
It's taking time before it's not 20 minutes. I think I have to point it.
Yeah, put it over there. Because sensor is over here.
Sensor is going out of range. So you have to keep over here, then it will get changed.
All right. I have 30 minutes. 30 minutes. Good morning, everyone. I'm speaking about strategies for securing research grants, and that is what I'm talking about. Yeah, came through SURAT. So now this is what I do. Number one, I'm an environmental microbiologist. Number two, I am also a biotechnologist. Then number three, I am an academic. Is it possible for me to use? I'm an academic entrepreneur. Then number three, or number four, there's also this place of spiritual intelligence and borderless learning. Borderless learning is talking about distance learning, just like we have the Zoom presentation by the first presenter today. Now, talking about academpreneurship and also borderless learning, I also have a YouTube channel And that is why we have here Dr. Lubenga TV is on YouTube. So that everything I know is not just ending in the classroom, it can also reach out to people all over the world. Now, this is a summary of what I'll be talking about in research grants, grant writing and securing of research grants. So I'm going to share my journey on grantsmanship, and then I'll outline some basic rules in the field of grant writing. Overall, I hope to convey that grantsmanship is a full-time marathon job, and it is not a sprint. Research grant. What do we mean when we say research grant? A research grant is finance or money given to individuals or research teams or institutions. Why are they given this money? So that they can carry out a particular research. The first speaker, he mentioned and quoted a United States physicist, and he said that the students continue to learn and learn until they learn something new. That means the researcher must continue to research and research until his research is a new research or contributes to the field or body of knowledge to solving some problems. How then will the researcher, with his own funds, his own money, be conducting research and research and research? That will not be possible. So the researcher needs research grants, so that the research grant is there, is able to do series of research, try different things. Why? Because there's a grant. You can't use your money to keep on doing research and research. If you're using your money, you try to manage the resources. But if there's a research grant, definitely there's a budget that covers everything you want to do. And in most cases, you have excess materials and other things, because there's a grant available. So that enables you to do a lot of things. Now let's move on to what we mean by research proposal or research grant proposal. These are essential documents. If you're writing a research grant, you need documents that you're going to submit, that you're going to ask by the funding agency to make available. So in the research proposal, there are a lot of things that are embedded therein, and this is what you are going to put, the researcher is going to put forward in this. Now, I want to talk about some research grants. These are not all, these are just a few research grants that I have won from 2013 to 2023. The first one was University of Illinois Staff Development Award. That is for as a staff of the University of Illinois and you are on your PhD, they give you the opportunity to enjoy that particular award if you apply for that. Then I applied for the Fulbright Scholarship Award, and I got it in 2015 August. I was in the US, and I think by May 2016 I was back in Nigeria. I also got the AAU grant. AAU grant is the Association of African Universities grants for PhD theses and awards. Then we also got the CETA Petroleum grant 2014. That grant is a team grant, not just myself, it's a team. Then in 2023, just last year, we have the US Embassy in Nigeria grant 2023. Now, these are just examples of some of the grants I have won. Now, this is the key message before I go on. You have to start small, then you have to think big, then scale fast, and most importantly, embark on your grantsmanship journey. Apart from this, what it takes to win is simply the courage to start and commit to continuous improvement. This is what it takes to start. Then in grant writing, you are going to encounter setbacks and success. I was telling you that In the last 4 months, I've applied to a series of grants and expecting results. It will be positive, it will be negative. So is that going to bother you? No. My role is to apply for the grants, and then you wait for what is going to come out of it. I spoke with somebody who has several grants from the US in 2014 at the conference. And I asked the woman, who is a professor, I asked her, how many grants? You have a grant workshop. How many grants applications do you write? She said she writes 12 grant applications. She applies to 12 grants in 1 year, and she gets about 2 of the grants. So when you apply to 1 grant, 2 grants, and you think, oh, I've applied, many other people are applying too. So grants are competitive, and that's why you have to keep applying. So if you don't get it, it doesn't mean your proposal is bad. It doesn't mean you are not good, but you keep applying. The first application, second one, third one, the fourth one, then you begin to master the art of grant writing. As you keep writing, it gets better. In 2014, 2015, I applied for twice, for the twice grants. Then the result came out. I didn't get it. I was very sad. I felt bad. Throughout that day, throughout that time, I felt bad. Because I also applied for full grant. So grant is maybe to come to India, but full grant is to go to the US. So I didn't get grant to come to India, which is small in my calculation. How then will I get grant to go to the US? I felt bad. This small one, I didn't get it. How will I get the big one? But funniest thing, I was in my office on one morning, and then I checked my mail. I got an alarm that I have an email. I checked my Gmail, and I saw the message from Fulbright. Congratulations, we got the grant. And the rest is history. And that was how it went. Then it looked as if I was a champion, that, oh, I knew how to write all the grants in the world. No, I just kept writing. Then I was in the US around October 1, that same year, 2015. I got a message in my mail from the Association of African Universities, small grants for thesis and awards in connection with the PhD. Then the letter said, I got the grant again. Why? Because I kept applying. So that is what I'm just saying, that there may be setbacks, but you have to keep applying. Then why do you need to apply for grants? Why? Why don't you just do your small research and move on? If you don't apply for grants, you're not able to do big research, and you're not able to do big research. So number one reason why you apply for grants is to get access to funding. Number two is supporting innovation and progress. I applied for one grant this last 2 weeks, and in the process, because the people that the granting body has a particular direction, has a particular interest, my own research has another interest. I have to skew my own research interest to align with their own. And in the process, I myself learn something just by applying for grants. Normally, my research is just, okay, look at this and look at this and look at it. But because that body is into something else, so I have to be able to link my research to what that body, granting body, is interested in. And in the process, I move my research and now link it to what is their own main interest. So this is what grant is going to do for you. You're going to learn in the process. Then another thing is address needs and solve problems. Then a grant also is for capacity building and professional development. Then it promotes accountability and transparency. Then it gives you recognition and validation. If you're a researcher and you have never won a grant, anywhere researchers are, I don't know what you're going to be saying there. You understand? You should have a series of grants that you've won as a researcher. So at every level, there's a grant for you. Now, how to find funding for your research. There are local opportunities that you can look at. Look at your local environment. Then look at maybe in Gujarat, maybe in Surat. Is there funding bodies in Surat, in Gujarat? Is there funding bodies in India, that's national? Then you are there funding body in the international. So these are the things you look at. Then we also have private sector that fund. There are many. And the issue is that I'm going to provide some lists, but those lists are not complete and cannot, nobody can give a full list of all research granting bodies. Looking for research grants to apply for is another job again. It's another job that you need to create time to do. Now, one thing you need to do is to focus on open or current grant funding opportunities. Currently, there are some that have deadlines. Maybe the next 1 month, the next 2 weeks. Look for them and apply for them. There are some grant opportunities that close in January, but they are going to open again in November next year. So you put that down and note it, so that you start preparing by November, you apply. There are some that closed in February and you didn't get it. Then plan for it next February, next January, February, I'm going to apply for that. So that is how it works. So you have to develop a work plan. So a lot of things we're still going to talk about now. Another thing we need to look at is, in terms of international, we have a weekly or monthly or sign up for alerts. There are a lot of opportunities indeed, and many other, even on ResearchGate, you can get grants. Even on, funny enough, some people advertise their grants on Twitter. Some advertise their grants on LinkedIn. So Indeed.com or thereabouts, if you register with them and you give them your research area, when there's any opportunity of research grant in that area, they will throw it into your mail. Then you check, maybe weekly or from time to time you check, and then you apply. So some research grants international are as follows: grant.gov, Foundation Center, Research Professional, Grant Partnership Center, Grant Select, Amazon Web Services, and Grant Forward. So research funding agencies, again, for completing research grants, you have all these lists. Therefore, research support, you have the following. For mobility grants, you have the others listed. Then for research for innovation also, you have that, what we have here. Now, these are 37 international funding agencies. Number one here is the campus grants. Number two is listed here, the Federation, Brazilian Federal Agency for the Support and Evaluation of Graduate Education. We have the IIE, CMPQ, and COST, the European Corporation in Science. We have that in Germany, the European Commission, and many. So you have to know the opportunities for research grant are so many. So it is the one that you look for that you will find and then you apply for. Now, as I was preparing yesterday, I decided to put this up. These are research grants in bodies in right here in India. We have the Department of Science and Technology, we have the Department of Biotechnology, then we have the Council of Scientific and Industrial Research, and many others right here in India. So, as I was talking about the national, you can explore that. Now, let's look at the structure of a grant proposal. When you have looked, you've obtained the grant, now you want to be able to know how to write your proposal. Number one is your title page. What is the title of the research grant you want to write? Then you have the abstract, or sometimes also called executive summary. What is it all about? Then you have the introduction, telling us what has been done before. Then you also have a future review, closely linked with the introduction. What is it? What work has been done on that area before? Then which aspect do you now want to address? Which problem do you want to solve? And that brings to the statement of need of problem statements. Then that will be your goals and objectives, the method you want to use to achieve it. Then what is going to be significant, what is going to be innovation. Then how will you know if you actually achieve what you said you achieved? How will you know? Maybe you want to produce, you want to work, to do something that is going to do it. Then how will you know that what that something is going to do or achieve, what you want to achieve? Then your budget. You have to write the budget. What are you going to spend on this, on this, on this, on this? Everything is going to be researched, you put it in the budget, even your transport to the sampling point, travel for members of the research team, and other materials you're going to use. Then don't forget to include your honorarium. That is what comes to you for the work done in the research. Then you have the timeline. How long is it going to take? Is it 6 months? Is it 1 year? Is it 18 months? Is it 24 months before you complete the research? So you put the timeline. In talking about the timeline, most funding agencies for a particular grant, they will ask, they may say, okay, this research will be completed in 2 years, like the one I submitted last 2 weeks, must be completed in 2 years. So you have to draw the research to cover for 2 years. That means your sampling sites must increase. If the the funding agency wants it completed in 6 months, you can't write the same budget for 6 months as for 2 years. That means you have to reduce the same title, the same abstract, the same introduction, but now it's going to be 6 months. So the sampling size is going to reduce, and some of the other things that you want to do, so that even they can even say 3 months. So you can do the same and reduce it. So it's going to achieve part of the total plan you have. Then sustainability plan of the stated production information and other information. Now, these are some of the essential tools for modern grantsmanship. In this modern day, number one is communication and social media tool. Communication and social media tool. When I came here, I said BIOTECH, because we are in Surat. And in Gujarat, BIOTECH is greeting. I can't say come here now and use my local dialect in Nigeria and say, Ekaro. You look at me like, what's he talking about? When I come here now and say, what's up, G? You look at me like, this, are you sure this guy is a researcher? But my research shows me that BIOTECH is the language of greeting in Gujarat. And when I brought it, I saw the response. If I come now and say, Ekaro, you look at me like, what's he saying, man? What's he saying? You'll be telling yourself that what is he talking about? Now, you are in your email. You now say your email is, what's email? Baddest guy. In what? I can't see from here. Baddest guy. Baddest Indian guy at yahoo.com. That's email of a researcher. That is a no-no. That is not good for a researcher. So look, good email your name and maybe your surname. The moment you use that kind of email, they look at this guy, he's not serious. If they give him this grant, he's a bad guy. He's going to spend it on something else. He will not do the research. So communication and social media too are very, very important. Also, across your social media pages, make sure you are projecting yourself very well as responsible, because they are going to check you out on social media. If you are writing a grant or LinkedIn page or Twitter page, it's all about something else. You're not projecting as a researcher. You're not projecting as responsible. They will check it and that will affect. Then number two is different resume style, resume or curriculum criteria for different applications. You are going to a grant in, let's say, Canada. It's different, their CV style is different from the Indian CV style. Canadian CV style is for your grant or for anything is different from that in Europe, in Germany. So you have to check and then you adapt it to that particular and then before you send. So that's another thing. Then the next thing is grant databases and directories. I've already listed some of them where you can be checking from time to time to know the grant that is out at a particular point in time. Then you also need project management software. Project management software can help you to guide you to say, okay, this is January, have I applied for any grants? These are the grants that I've listed that I'm supposed to apply for in February. So it will help you to manage. Then you should be able to have somewhere you can tick also, I've applied for this grant, I've applied for this grant, I've applied for this grant. Then we also need the budgeting software. You can use Excel, you can use Google Sheets, and there are many other software that you can use. Then proposal writing templates. It is not, most people, they say a grant application, but they don't apply. They say they are interested, but now they say write about this, write this. They don't have a template for their proposal. So the time for them to sit down and write it becomes cumbersome. So even before the grant form, you see the templates initially shown, the title page, introduction, lecture review. You should have it. Have like 3 or 4 or 5 different on your research area. Okay, they ask for this, this is available, this is available, this is available. So when the grant opportunity comes, immediately you can pick any of the templates and modify it. There's no how, we still need to modify your template. But at least it's a template that you have that you modify. But if you don't have the template, that means you have to start the process, and maybe a lengthy one. Then collaboration platforms. Google Workspace or Microsoft 365 or Degree. On these platforms, it makes you to be able to organize your work properly. Then you also have research tools you can use for research. And you have customer relationship management tools that you can also use. Then data visualization tools that you can also use. Then we use examples to take your infogram to create compelling visuals. You will see at the start, I showed what I do. Here, I saw this somewhere where somebody showed what he did, and it's not exactly like this. But when I saw it, I liked it. And I look at it, this thing is not done inside of, you didn't do it inside PowerPoint. So, and I know how to use Canva. So I went to Canva and I did this, and I copied the JPEG from Canva and I pasted it here. So when you are writing a grant, you need data to visualize, that you want to see. Now you are applying for something, everything I do is here. And you know, it drives, if it's a grant application now, so this one is going to be put in a separate place, and this person is like it has something to offer. So these are some of the things that can help you in interpreting and presenting your data. Okay, so I'm here. So then grammar and editing tools are also important. Grammarly, Drupal checker, SEO, Realizing checker, and many others. Then you need the cloud storage solutions. So all these are going to be tools that are going to help you. Now, let's go to the next one, which is talking about emerging trends and focus for winning grants. When we talk about grants, there are some areas that are areas of focus. Number one is equity and inclusion. We're not just talking about the Indian government, but I'm talking about global, international, worldwide. You are applying to grant, a worldwide grant, you want to see equity and inclusion. How does this project, how does this research makes for equity, and is it inclusive or is it segmented research? It shouldn't be a segmented research. It should be a research that is all encompassing. So number two is environmental sustainability. There's attention, there's funding in that area. So you look at areas where there's funding. Even if your research is not in these areas, you try to link your research to these areas I think you get what I'm saying. We try to link it. As microbiologists, we should not link your research to environmental sustainability. We should link it with artificial intelligence. That is a hot thing happening now. Some people, when ChatGPT came out, they said, oh, ChatGPT, it's bad. ChatGPT is it bad? It's not bad. It's like a calculator. I ask you now, 2 plus 2, you answer 4. Okay, 2 plus 2 plus 2 plus 2 minus 3 plus 2 plus 5, divided by 3 and times everything. Yeah, you're using it. Before you finish, somebody will press the calculator and told us the answer. That is what ChatGPT does. If you are not good and you go and use ChatGPT, you are going to get rubbish out. Even to use a calculator, you must also be sound. You must also know BODMAS. The same thing with ChatGPT. So that's just that about that. So you must talk about how your research also linked with artificial intelligence, the impact. What impact is your research going to have on the environment, on the community? Then health and well-being is another one, another area where emerging trends, the focus on where grants are. Then education and lifelong learning. Then community-led development. I will pause in this area. Because most of researchers, they focus on laboratory research. Okay, let's take, for example, you as a microbiologist, look at the microbiological quality of raw milk that are consumed in different places. Because people consume raw milk. There's a place where they keep cattle and buffalo around where I stay. So most times sometimes I take a walk because sitting down for a long time is not also good for health. So sometimes I will take a walk to the other junction, then I walk back to buy something. So my way, you see some people, they press the milk from the cattle or from the buffalo into something, they put in that. How much is that? 60 rupee kg or something? That is raw. And there's a research that has been done that shows that raw unpasteurized milk contains microbes that are not good for health. And we've done a research on it. Now, community-led development. How do you now go to the community and tell them that taking unpasteurized milk is not good? You can look for NGOs that can give you grants to go to the community to tell them, not just to be in the lab working, to tell them that raw unpasteurized milk is not good for health. So some people are still taking it, they say nothing's wrong with it and everything, but from the research finding, it's not healthy. Then another area is cross-sector collaboration. You are in India and you are just doing your research with only Indians. You don't have a collaborator from US working on the same area. You don't have a collaborator maybe from South Africa, maybe from anywhere. You should. The research I submitted this 2 weeks ago is a collaborative research. So if you're just working in Asia and your collaborator is in Asia, you cannot apply for that grant. If you are working in Africa and your collaborator is in Africa, you cannot apply for that grant. So it's intercontinental collaboration. They want to see that okay, one person in the research is in Africa, the other one is maybe in Asia. One person in Asia, another one is in Europe. So look at this and start preparing. You need to start preparing yourself for all this. Then evidence-based interventions is also something that people are looking at today. Now, before I round up, I have these suggestions. Number one is that you need to read the application instructions carefully. You read it carefully. In the research grants, you're given instructions. Do this, do this, do this. In fact, some applications, they will say this, they will give you what they want, some points about what they want. Most times what I do is, they've given me the point they want, I take their own points, and I give it back to them, and I develop it. I will not go and formulate points from another place to give them. The point they want, okay, the person apply for this grant must be this, must be this, must be this. So in my response, yes, I am this. Exactly what they say they are looking for. So that is read the application instructions carefully. then collaborate with other investigators. Like that grant I said I'm applying for is intercontinental. And then when you are applying, 2 people in Europe are applying. That is already off. The person has not abided by the grant's instruction. Then collaborate with other investigators. If you're a microbiologist, you need an investigator in chemistry. You may need somebody in another field, different from your field. And so you see what you can do together. Then learn more about grant writing. Then the other thing you need to do is know what to do and how to do it is important. That means knowing what to do and then how to do it is important. The last point is let a research team demonstrate 4 qualities. So you must have a research team. Have a research team. Number 1, multidisciplinary. Don't just be in one area alone. Spread out in different areas. Form a research team. I have people that contact me that okay, I'm applying for this grant. They are in chemistry. Give me your CV. I'm in microbiology. Give me your CV. I'm putting you in. I am applying for a grant and I need somebody else. I contact some collaborators. I need your CV to be able to submit this grant. So, multidisciplinary, multi-institutional. Not just one institution. It's even in paper writing, it adds weight to it. Then collaborators and then partnerships. So now in conclusion, it does not matter how many resources you have. If you don't know how to use them, it will never be enough. Look at this man. He has plenty of ladders. But just one ladder out of those ladders is enough for him. But they didn't know how to use them. So that is what this information is all about. If you know how to use it, it's going to move you to the next level in your research. So I want to acknowledge my university in Nigeria, University of London, also acknowledge Ukata University where I'm visiting currently. The first person to my left is Professor Christian Morty. He is instrumental to the collaboration between my university in Nigeria, University of London, and bringing us here and also working between the University of London and Ukata University. So these are other people. I think this is somewhere in Hazira where we went to see the environment where we want to take our sample for our research. Thank you for listening, and if you have any questions, I'll be willing to answer. Thank you. Any question? Okay. Maybe if you have a question, can come towards so that I can hear you. Yeah, come forward. Please. Yeah, go on, sir.
As you said, you were the Fulbright fellow, and can we hear your journey during the Fulbright fellowship? Have you how have you been into the US university, and what have you done in your work in the university? As one of my seniors also have been accepted into the Fulbright fellowship, but it is about the lecturership. As our biological area, its domain are not accepted as like lecturership, but it is based on the research and on what.
Okay, you want me to talk about the Fulbright, my experience or something?
Yeah.
Okay.
Thank you.
Thank you. The Fulbright is a competitive. It's competitive, but anyone can get it. Anyone can get it. People see Fulbrighters as smart, but I also see everybody here are very, very smart. So you look at him and this guy is a smart guy, he's got a Fulbright. Wow, he's smart. But you also you are smart. In fact, you are smarter. Just that you are not applying. You are not applying. You are not applying. When I started getting the grants, I sat down, I looked at it, so I'm now a champion in grants, anything grant now, I know about it. It's because I was applying. Many people even no reply, no response. But I kept on applying. And based on that, I know what I need to do. But that still does not mean that anytime you apply, you're going to get it. Now, the first time I applied for Fulbright, a year before I got it, they did not even reply. They didn't even reply. They didn't even say they saw my application. They did not get back to me the first time. I didn't give up. The following year, I applied again. So the following year, when I applied, the first thing they did was to inform me that I've been shortlisted. Then when we were scheduled for an interview at the U.S. Embassy staff, maybe guest house or something in Lagos, in the former capital of my country, which is like Mumbai. Mumbai of India, Lagos, Nigeria is like the Mumbai of Nigeria, while Abuja, Nigeria is like the Delhi of India. So I went there. I traveled 4 hours by road, reached there. So in the morning I was there. We were many, about 15 of us. So they called us in one by one. It was a panel. There's a large table. So some people were sitting. I sat here. Some people sat there. Some people sat there. Some people sat there. So the chairman of the interview sat on my right. Others sat. Some they are psychologists, just watching, not speaking, but watching my body language to know whether I was lying or whether I was telling the truth, to know all those things that happened. Intelligence. Some were asking questions. When I got there, they told me that I don't know anything, that I'm the one that knows everything. But when I started talking, with some questions they asked me, but you say you don't know anything, how did you not ask this kind of question? So it almost threw me off balance, but I stood and I answered the question, and I answered with facts and figures based on my research, and it was okay. After that, I was told that I passed the interview. We were scheduled for TOEFL, test of English as a foreign language, so we went for TOEFL. I practiced on text then, online. That's why the internet is very, very powerful. I went online, I stayed back in my office then working. I took the test of TOEFL, I took it like 3 times, 3 tests. And the 3 times I passed it. That's the practice. So I went for the main test on the day and I passed it. That's the TOEFL. Then the IIE, Institute of International Education, they work with Fulbright to arrange everything. So they got an institution for me in Oklahoma State. So everything was set. They paid for the TOEFL. Then they scheduled the day I was to go for the visa interview. Visa interview was just a walkover because the process of the Fulbright application is handled by the embassy. So the visa interview at the embassy is just like going to say, brother, it's not about are you going to give me a visa or not. Immediately after, we just asked some questions. They look at my documents that they sent to me. They say, no, this printout is not good. In fact, they gave me clearer printouts so that at the immigration I will not be turned back. So all those went that way. After the interview, I was told my visa will be out the following day. So I picked it, and then the following week I traveled. So getting to the institution, everything went fine. You know, it's the one I went for is in connection with my PhD. So it's research. So I went to the lab. To look for a lab based on your proposal, you are attached to a lab that is working in the area of your research. And I went and I learned a lot of things. Most of the things I was doing back home were not, I will try, but I learned better things from there. And they have equipment and other things. So we did a lot of things for 9 months. Research, and then took part in the life of the university. We have seminars over there. We have what's it called? Journal club. So every Monday there's a talk. Then on some Fridays, we have happy hour, where a particular lab we host the whole department to some eating. So that's where we have time to interact with, because every time everybody is in his lab or her lab working, so don't be happy hour, we get to meet ourselves and interact. Okay, you're here, after 1 hour, you go back to your lab. So basically that's how it went. You work more in your lab, so the Fulbright, they give you a particular amount of money every month. They give you money they pay for my ticket also, they pay for the flight and everything. So they pay themselves, they give me the money, they paid, and that was the best airline in the US, that's Delta Air. Just direct flight to Atlanta, went from Atlanta to Oklahoma. So when I was coming back, the same thing they paid. Now they pay some stipends every month. So from the stipend, there's money for laptop at the beginning. So that's at then it was $1,000 for the give you for laptop, $500 for books. So in addition to some monthly stipends. So from the stipend, the first time you get there, they give you money for 2 months, so that you can settle some settling down bills. So I got an accommodation myself and every other thing. So they don't interfere with your personal life. So anywhere you want to stay, you stay. The important thing is that you go to the lab and do your work and get back to your home and leave. I don't know if I answered the question. Hope you are satisfied. Anyone, do you want to add to that? Okay. Any other question, please? All right. In the absence of any question, I will take my seat now, but I want to inform us that I am available. Okay. What? Okay. CITA Petroleum, CITA, you can Google it. CITA Petroleum is a company that they are doing aviation fuel. They sell aviation fuel. My area of research is environmental microbiology, precisely bioremediation. So CITA Petroleum sells aviation fuel. So my supervisor was the one that got the grant, but it's a team. In the team, I was like the youngest. I was still on my PhD when the grant came. So CITA Petroleum sells aviation fuel. So what they ask us to do is to look at the quality, the microbial quality of the aviation fuel. So we travel to 3 locations where they have their farm towns. We travel to Abuja, the capital of Nigeria, the airport, where they have the farm town. We travel to Lagos, where they have their farm town at the airport. Then we also travel to Port Harcourt, the CITA facility. So we take sample from the bulk fuel. That's what is called bulk fuel. The bulk fuel is what they supply directly to the airlines. So, yeah. What?
Is it available only for the academic students or for everybody?
This is it's not always available. I think they just had something to do at that time, and I think that was the only time. That was the only time they did the grants. That was the only time CITA came up. So that's why I said there are some grants that are just once, twice, some they stop, some they continue. There are some that are yearly. That's why I said the ones that are yearly, if you miss the one for this last January, you know that next January is coming out again, so you prepare to apply. But CITA is just one off. You just wanted to see, and then that was what they did. So it's not a yearly thing. I think they have a link with IATA and other things, so they don't need that to show that they're also doing something. Any other question? So I want to point out that I am available for collaboration in your research, so that if possible we can also work together. If you have a research going on, we can apply for grants together, and we can also work together. And I also advise you seek other people that are into grant writing and others, and then you see what you can achieve. Thank you very much.
Thank you very much, sir. Hello. Hello. Thank you very much, sir, for your inspiring presentation on how to get the research proposal, what are the components of the research, how to get the grants and everything. I hope this young generation will ignite from your presentations. And as you have said that keep trying and keep trying, don't lose your courage. One day you will definitely get the grant. I know that the Fulbright Fellowship is the highly precious grant to get there, but everybody cannot reach up to that level for the interview level even. But every small grant is precious to start any of the research. If you are doing a qualitative research, in quality of the research, you will definitely get the grant, but if you have to go for the trying and trying, you have to go for the applications. Thank you very much, sir, for your precious presentation. I would like to request Dr. Farzin Paravia to felicitate Dr. David. On this occasion of Web of Microbiologist, we thankful to both the keynote speaker of our session. Now let us move forward and go for the best research presentations. For this, I would like to invite our today's chairperson, Dr. Himanshu Bhimani, Associate Professor Microbiology in Navsari Agriculture University. His specialization in extremophile, enzymology and plant pathology. He has more than 15 years of the teaching experience in UG and PG level and more than 10 years of the research experience. He has a couple of research paper and project in his field. Welcome, sir. Another chairperson of today's session is Dr. Dhara Gami, Assistant Professor, Microbiology Department of Bioscience, VNSGU. She did her Masters from MS University and PhD from the VNSGU. She is actively involved in agriculture and environmental microbiology research, and she has also have a couple of research papers and projects in the same field. I welcome both the chairperson and to conduct this best presentation paper and award ceremony of today's Web of Microbiologist session. Over to you, sir.
So basically the sixth research paper we are taking over here, that is for the last 3 years. So as sir has told in the initial inauguration session only that Web of Microbiology was awarded the best research paper and best thesis award annually, but due to some circumstances in between we were not able to continue it. So right now we are just giving the award for all the 3 years publications, and these research publications are among the each year category. So we hope that you will get the idea that how much increase in the impact factor is going in the Gujarat. The basic reason behind that was that only that at least there should be some kind of the benchmarking. So we should know that what are the level of the research which people in Gujarat typically in the microbiology related area they are doing and how it is progressing, right? So we are lucky enough that out of 5 persons are here only, so they will be presenting their work. We'll ask them to have their presentation within 15 minutes. But basically, as there are so many young students, I would like to tell them that you just give the story about your research paper, that how much it was difficult, how many times plainly tell that it was get rejected, and what kind of the comment you have faced after, how you get the succeed to get entire publication. So just to insist that point that at least others can learn also from your experience. Right? So thank you very much, and I think now Himanshu sir will take over. You are welcome, sir.
Hello. Slow to echo reduce. Hello. Good morning, everyone. So we had a fantastic session in the morning with two keynote speakers, and now we are moving to the next step of 6th National Conference on Contemporary Development at BIOTECH, Bioinformatics Interface, and now we are going to have, as mentioned by Dr. Rajesh Patel, 6 research papers we are going to award, and the duty is we are having 5 people physically present over here. So I request, first of all, Dr. Neelam Nathani, who is presently working with Gujarat Technological University, Ahmedabad. So I request audience too to appreciate all the 6. Please come in. Have all these 5 awardees have given their PPT to this presenter. Make sure that your PPT is already there. Next would be Subhrata Hetri.
So, good morning everyone, and first of all I would like to acknowledge Web of Microbiologists for giving this opportunity and selecting this publication, and also VNSGU Department of Biosciences for making this platform available to discuss this particular paper, because for me this particular paper is actually very much important, and this is one of the parameters which taught us a lot of things by publishing. So as already Rajesh Patel has said that also discuss the journey, that would be one of the very important things. So this is a paper which is published in the Nature Publishing Group. Currently the factor is around 9.8, and it is 309 metagenome assembled microbial genomes from deep sediment samples in the Gulf of Hyderabad Peninsula. So the story begins with that this paper was actually rejected from this journal. And it was a blunt rejection in the first revision itself, because we made a very minor error of choosing a type of plot. We chose a widen plot which had some narrow point of line reaching 0, which actually could not be. Any data cannot be 0. If we are presenting something, statistically it was not 0. So the journal had, after first revision, rejected this paper. And then we made an appeal. Nature has a very good opportunity. It asks us to make an appeal. If you feel that something has gone wrong, so we made an appeal to the editors and we requested them that because of the choice of graph, our data is not visible appropriately and you are finding it to be 0. And then again we had a minor revision. All the reviewers agreed that from the scratch, we had given the data in Excel sheet. So that was the main point. While submitting, it's better if you give all your raw data. So we could also, the story has many moments, like we had a very drastic, and this was the first journal targeted. We had actually planned objective to publish in this particular journal. So there were no rejections prior to that, and there were no options to publish in other because we had planned it according to this journal. So these stories do matter, and yeah. So here I'll just discuss in brief in 10 minutes that what we were trying to study. There were questions in our mind, and what answers did we get. So the major thing is that, as already Singh sir also mentioned in the earlier session, that metagenomics and molecular we are reaching very much at par with the international or the global research. So this is what's also our question, that are actually microbes everywhere, and if they are, then what are they doing? And if they are there and doing something, are they doing it 365? Are they doing it every day same way? So for that, we wanted some answers from some different and ecological niches. And as we all know, there are two methods for studying the microbes. There is the conventional culturing method and there is the molecular approach. So by the conventional culturing approach, the issue was that almost 99% of the microbes are not cultivable. This is a very well-known thing. And then came the term of metagenomics. So this study was the advanced version of metagenomics. So what we are actually trying to do is to get individual genomes. And nowadays it is called metagenome assembled genomes. By that time there was no such terminology. So we used to call it genome reconstruction. So this is now, it has given a specific terminology called metagenome assembled genomes. There are specific parameters to get them done. So what we are doing, we have a pool of puzzle and we are trying to create some animals or some figures out of that. So this was a very broad definition. I will not go into the detail, but yes, I would, as there are so many youngsters, I would always suggest if you want to actually know what current research is going on, please follow good researchers in your field on Twitter. The Globe World is publishing and mentioning a lot of things and their troubles and their stories on Twitter. So one of them is Joan Edisman. Currently also she's working and she's doing a good job. And she had introduced the metagenomics terminology. So our target was to understand the uncultivated population, unannotated, and also known as the microbial dark matter. And these were the candidates. So the term candidates means that such a phyla or a taxonomic assignment which does not have any cultural representative. So we wanted to expand the phylogenetic tree, basically. So currently, are there any other major projects which are being done? So there is one of the big projects, and the Stara Oceans project, which was started in 2009, but still they are just analyzing and interpreting the data. The project, the expedition is completed, the sampling is done, but the data is so huge that even publications for now are coming out. Another, there is the Genome Tech Kit project, the Earth Biogenome project. So there are several such projects as a consortia going on in the group. And one of the recently approved is by the NIO. The central government has approved the expedition of NIO. As you can see, the path is all given where they are going to take the samples and study the biodiversity in the entire our Arabian Sea and the Indian Ocean. I just give this, but this main thing was that it is 0.1% of microbes in the oceans are known. If we go to gut, still the ratio has increased to 2 to 3%. We are able to calculate 2 to 3%, but going into an extreme environment, it is still a very less proportion wherein the data is available. So main thing was how we collected the marine sediment samples for microbiome analysis. So we had 3 sites selected. As we all know, Gujarat has a very big coastline. So we selected both the gulfs. Now one of the Gulf of Khambat, has a lot of different sedimentation process. It has Alan on the way, which leads a lot of petroleum contamination because of the ship breaking. Then it has Birma also alongside one of the shore. And while on the other side, Gulf of Kutch is very much diverse. So we took 4 samples each from both the gulfs, and we had one sample as a different environment of open ocean, that is the Arabian Sea. Because the gulfs, the sediment will be constantly rotating, while the open ocean will have a more stabilized sediment. So further, how we process the marine sediment samples for the omics, so we had taken a 1 meter core, 100 centimeter apart, and we divided the core into top, middle, and bottom. We took 10 centimeter from top, middle, and bottom. And then we performed the metagenomics on Elimina ISIC 4000. And this is the profile which already says that the environments are different. There was a very different salinity specifically under pH at different samples. So K represents the Kutch and C represents the Khambat. And we could see that GeoCS1 and CS2, where the Nirma and Namita is a different profile coming compared to the other parts. So obviously, if you give some extreme environment, your microbes would be different, and they would be performing different tasks also. So we tried to mine some microbial genomes out of the entire data, and we could find around, actually we could find 1,000, but then as I mentioned, there are criteria. You should know what, if it is a complete genome, you should know if it is not contaminated with other sequences, because we all know that every species is only 1% different. The genome is only 1% different. So looking at all the criteria suggested, we could come down to 311. But again, during the journey, 2 of the bins were requested by the journal to be omitted. Again, because it was not phylogenetically ending anywhere. It was coming out as a new archaeal phyla. So I'll also mention that where that journey has reached here, we are about to publish those 2 genomes now at a different level. So this was 21, and in 24 now we are very much confirmed that it is just a new order. So you can imagine the variation of the improvement in the evolutionary tree. In 21 it was not even classifying anywhere, and now we can very definitely say that it is from Thermoproteota phyla, and it is classifying as a new order. So this is the 3 years of gap and how much microbiology has moved ahead. So these are a few of the phyla and number of bits which we got from different samples, and we can see clearly that the Dutch had very different microbes while the Khambhat had a very different microbes. So there were about 5 archaeal and 18 different bacterial phyla that were observed. And there were a few very, obviously it was sediments, we expect organisms to be from the sediments, so from the sediments we could, Proteobacteria as the most dominant, then there were 60 bacteria, Helpline, data bacteria and Lactomyces. So one of the main objectives which even Singh sir had mentioned in the morning is that we need to club the molecular data with the culture. So our very first objective initially was to somehow see what the functional genes are and try to calculate these numbers, which are of some importance to industrial applications. But definitely then there are fund branches and we proved that. Let's see if we can move ahead with the culture part. So Proteobacteria was the maximum, there were few chloroplexi, and the rest had a very less proportion of about 2.1 to 5%. Similarly, with the archaea, there were 3 different phyla in the Gulf of Khambhat, 4 different phyla in the Gulf of Kutch, and these represented a very minor proportion of around total 3% of these. So later we wanted to see that how are these distributed. So what we found was there were specific features like Proteobacteria was highest in most of the samples except 2. Then this particular phyla was very much abundant in GeoCS1. So GeoCS1 is the sample where iron shell breaking yard is the nearest on the shore. So what we can expect is that this could be having some potential in pollutant liquidation. Further, in GeoCS4 again we have Thermoproteota which was not present in anywhere. And from, as the name itself suggests, Thermoproteota is an extremophile which could have potential enzymes to work at high temperatures. So this is what is actually published in the paper, and I would like to say that we have not left it at 2021. We are still continuing it. So this is what we are currently doing. We are trying to understand how these microbes are going for biogeochemical cycling of carbon, phosphorus, and nitrogen. So this plot we have recently seen that there are many organisms which are doing multiple work, that is carbon, nitrogen, and sulfur, all 3. There are few who are only having carbon cycling genes. There are few only having nitrogen cycling genes, and we are trying to understand that how this biogeochemical cycling is done by these veins. So looking at the carbon cycle, again there was a very wide distribution. The red one is Khambhat and Kutch and the Arabian Sea. So Arabian Sea, which is obviously a more stable environment, had more carbon cycling because the diversity is more, and the rest had around 20 meters. Methanogenesis is totally absent in all the 3. And this is the entire cycle comparison to see how the carbon cycling is done by these microbes, not the entire community. Similarly for the nitrogen cycle and for the sulfur cycle. So we could also find a few organisms which are very specific doing the sulfur cycling. So based on this, we are trying to understand that what input sources are there and what output sources are going on. So we are about to communicate this paper also, and we are again targeting even some community networks, like for this cycling, which organism is helping the other? Suppose one organism is producing some sulfur intermediate, then what is the next organism which is? So the networking kind of a cytoscape work is also being done. And yes, so this is what it is that conclusion of the thing is that we need to understand the ecology as a whole. We need to integrate some biocycling, some biomarkers, microbes, and we need to validate it through the real-time cellular data also. And we ultimately can use it for the benefit of the humans. So I would also at the end like to thank my current team and the team at that time, because this is a pretty different paper. But we are lucky enough that one of the students who was working at that time is now my PhD student, so currently also involved in the same work. And the other one is in Nagpur, Ahmedabad doing PhD. She is in Germany doing her PhD. He has left for Australia in Monash University, and he also got the Marie Curie Fellowship, and he is also working as a PhD scholar at Monash University. So obviously at the end is the team that matters, and the idea, concept of metagenome analysis was given by Professor Chaitanya Joshi, who was there yesterday. He had given me this idea as a very raw idea back then in 2014-13 when I registered for my PhD. So obviously the source who gave the inspiration. So thank you. And happy to answer some questions.
Thank you. Very interesting work, and it is very fruitful to all the young researchers. I would like to request Dr. Himanshu Bhimani sir to felicitate Neelam Nathani ma'am with a token of love of memento, book and bag. Next is Dr. Subrata Hathi, Kamdev University, Anand.
Once again, humble request to all the speakers that try to finish up in a stipulated time, that is 15 minutes. If someone is finishing within that, we can accommodate one or two questions also.
Very good afternoon to the chairman and co-chairmen. I'm very much thankful to the organizer of the conference and the web of microbiologists who have taken initiative to award the very important work being published from the state of Gujarat. So my work was on exploring the potentials of antioxidative, anti-inflammatory activities and production of bioactive peptides in lactic fermented camel milk. Basically, I'm working in the peptidomics. So my job is only to purify the proteins and see what kind of biofunctional properties are there in the sequence of the peptides, and we use different softwares to analyze those peptides. So before going the work, I will finish within the time as chairman have requested. That work I was initiated in 2013, and I was getting shortlisted in the GSPTM for this project. But somehow it is being rejected because the question was that first to increase the camel number of camels, not the milk. But my job is not to produce the breeding of the camels. But the very fortunate thing is that I did not leave it. We didn't get the project from the GSBTM, but I have started the work from 2014. One of my students, he worked on anti-hypertension. Now he is in Australia, University of Queensland. He is doing the PhD. Just 9th and 10th March, I was in Bhuj. There is a conference on National Camel Milk Symposium done by Sagar Dairy. Okay, so they invited me that you have done a lot of work on camel milk basically. So you come and deliver a lecture. I was there for 2 days, and they visited to the place where the camel is grazing. and then I interacted with the farmers who are keeping the camels. I said that what about your idea about keeping the camels as they are walking daily 20 kilometers? Okay, so they said that when the Amul take over the camel milk for preparing different products, we are getting a good amount of money, and now we are increasing the camels. So now just we can understand that how we can be increase the camel numbers. So I was there, and the farmers are very much interested to increase the number of camels because of the anti-diabetic properties, which I am now working with the Amul. We have done the animal study, now we are working for the clinical study with the Professor Hospital and Anand. So I'm not going to give you the introduction, but just I'm going to the work which we did because the time is very short. The antioxidant activity through ABTS method we have estimated, and we have found that KCL3, lactobacillus fermentum, they give the best results when we are optimizing at different hours intervals compared to the other cultures. Then hydroxyl free radical scavenging activity, again you can see that KGL3 is giving the maximum hydroxyl free radical scavenging activity than the other lactobacillus cultures. Then superoxide free radical scavenging activity also, we have estimated to see that how this antioxidant activities are increased by following different assays. Then we have checked the protein, because I already told that my job is to see the proteins, how this protein is participating in these assays and how they are contributing to different biofunctionalities. So here we have measured the peptide content, and here we got the two lactobacillus giving the best results, HL4 as well as the M8. Then we have optimized the peptide productions by increasing the rate of inoculations and the incubation times. So we have found that after 48 hours of incubations and 2.5% rate of inoculation of that particular culture, stage L3A, has given the best results on the peptide productions. Next is the purification and characterization of these peptides, which are having the antioxidant activity. So we have fermented that camel milk by optimizing this rate of inoculation, 2.5% rate of inoculation, 48 hours of incubations. And then we pass through different cut-off membranes, 3 kDa and 10 kDa. And then we have checked the different activities again. But permeate is giving the best results compared to the retentate, means low molecular peptides, so low molecular proteins are giving the best results in case of antioxidant activity through a BTS method. In hydroxyl free radical scavenging, KTL4 is giving the best results, and NK9 also in permeate. Then superoxide free radical scavenging assays, again permeate is giving the best results. Low molecular weight proteins are giving the maximum activity. Then we have checked the peptide production also by following the same conditions. Again KTL4 is giving the best results. Then we have checked the peptide productions by HPLC. This is called percentage RPM, relative proteolytic activity. Again, NK9 and KGL3 is giving the maximum percentage RPM. This is the HPLC chromatograph. They are producing at different cut-off membranes. We have also checked the anti-inflammatory activity by raw macrophage cell line 264.7. We have basically used the LPS, lipopolysaccharide, to induce the inflammations against TNF alpha, IL-6 and IL-1 beta. First we have checked the cell viability, then nitric oxide productions, and we have found that the low concentration is giving the maximum cell viability around 0.25 milligram per ml. And when we are giving this 0.25 milligram per ml fermented camel milk, these inflammatory markers like TNF alpha, IL-6 and IL-1 beta is reducing significantly compared to the LPS. It's very clear from the picture. Then we have checked the peptide profiling, means the protein profiling through SDS. These two, first is the ladder, and second, third, and fourth leg is the unfermented camel milk, then fermented, and then permeate, 3 kDa permeate, 3 kDa retentate, and 10 kDa permeate, and 10 kDa. in the part milk you cannot find any protein bands because it is completely hydrolyzed through the fermentations because the part milk is giving the best results. Then we did the 2D page to purify those pods with the help of the digestion method. And after getting the purification of those pods, 2D spots, we have done the LCMS. And after doing the LCMS, these are the sequences we have found out. And these sequences from our own breed, this is actually catch breed from our country because no one has done this job before. So in 2014, we had some problem to compare the data because there is no camel milk database. So we have created the database from our own side and we have submitted the BIOTECH databases. And now these camel milk peptide sequences are matching with the other bovine protein fractions like alpha caseins, beta caseins, and also some other plant proteins like chickpea, also the star proteins, and this sequence also matched with the alpha S1 casein mostly because casein part is 80% of the total milk. These are the sequences we have found it out. Mostly these LLNEK sequence has the more potentiality because their peptide actor score is more than 0.8 or 0.9. So we have selected for the molecular docking. And these two peptides, LLNEK and IYTMPQP, we have done the molecular docking with this HMPO. HMPO is the human myeloperoxidase enzymes, which is basically responsible to cause the oxidations. And these peptides have the capacity to bind these enzyme, myeloperoxidase, which cause the oxidations. So both the peptides you have selected on the basis of the peptide actor score. There is one software to give the biofunctionality and peptide actor score. And then we have done the dynamic study with these enzymes. And that enzymes are getting completely bound with these 5 amino acid residues peptide, and this is the around 9 amino acid residues peptides. So, in conclusions, the camel milk fermented with this organism lactobacillus plantarum HL3 exhibit the promising antioxidant activities and anti-inflammatory activity. 3KD reported the maximum antioxidant activity using the ABTS method, all other antioxidant methods. It was also confirmed that such fermented camel milk was certainly an attractive source of the bioactive peptides and antioxidant activity. And based on our findings, the lactobacillus plantarum HL3 these are our own cultures, should be used to investigate new antioxidant peptides from fermented camel milk. Clinical trials will be required in future to basically validate the claim, and further studies also required for demonstrating the order of biological activities of the iron peptide from the lactic fermented camel milk. This paper has been published in 2021 in Food Bioscience. Thank you all.
Dr. Subratov has finished within time, so we can have a few question answer also. Dr. Subratov, you have done a very good job in the sense, I would say. You have started working in this area, as Amul is also focusing on now. This is a landmark, what we can say. Doctor, as you have worked on fermented milk, so what is the nutritional status of raw camel milk?
Raw camel milk, because you see that I am working on the peptides. I am working on the peptides productions because peptides is only produced when enzymes are being given through enzymatic hydrolysis or through fermentations, because lactobacillus are the good producers of the proteolytic enzymes like peptidases, aminopeptidases, proteases. Okay. Now you are asking about the raw camel milk. As I interacted with the farmers in the Kutch area, like 9th and 10th, I was there in March. So they used to drink the raw camel milk because they went 30 kilometers away from their house and they drink at least 1 liter or 2 liters camel milk. This camel milk is very light milk compared to the cattle and compared to the cow and buffalo, compared to the fat percentage of protein, and a little bit salty. So I asked them that, do you have any kind of diabetic patient in your family? Well, generation after generation don't have. And some of the people who have sold their camels after seeing that this camel milk has some kind of medicinal values to control or manage the diabetes, now they are also purchasing the camels and keeping their home. So one thing is that the camel milk has an anti-diabetic effect. I'm still working on it. I have published around 7 papers on anti-diabetic properties. Now I am working on the animal trial and clinical trial with the fund from Amul. Amul is giving me the fund to conduct this study because they are selling camel milk chocolate, camel milk powder, camel flavored milk, camel milk ice cream. All these products Amul is selling, and the product is prepared in the Bhuj area. There is one dairy called Saral Dairy. They have established it and they are selling all over the country. And camel milk chocolate is now they are exporting. And another disease you may have heard about in the time of Corona, one lady from Mumbai, she tweeted that her child is having autism and she needs every day around 500 ml camel milk to manage it. And on the time, it was very much difficult to get that milk every day. So she tweeted that she requires that amount of camel milk for managing her children's disease. So the Prime Minister requested to NRC, National Research Center Camel in Bikani. So they sent the camel milk to the Mumbai through luggage hand train on the time the passenger train was stopped. So you can see the raw camel milk has a very good impact, but nowadays as a microbiologist or a dairy technologist, I would suggest that the quality of the raw milk, you have to check it before consuming. It has a very nice nutritional values. As I have not read the introduction, but it is rich in vitamin C. It is rich in some of the chemicals, some minerals in raw camel milk. So it has a, but another important part is it doesn't have the beta lactoglobulin. Some of the people having, if you take the bovine milk like cow or buffalo milk, you have some kind of allergenicity. The camel milk doesn't have beta lactoglobulin, which causes the allergenicity to you. So camel milk has a very nutritional as well as the medicinal value. Basically, we are now targeting to explore their medicinal values compared to the nutritional value, so that it gives some kind of management of disease like diabetes or autism or edema, which can be managed through. No, I am not telling that it is medicine, but it can be managed somehow.
Any question from audience? Yes.
Sir, it was a very nice study, but my question is, I am concerned about, can you please insight what is the effect of this product on the lactose intolerant individual?
Lactose intolerant people?
Yes, sir.
For camel milk or any kind of milk?
For particularly this camel milk.
Lactose, because you see that the Amul is already selling the lactose-free milk. Those who are having the lactose intolerant problem, basically what happens in your intestine, it doesn't produce the beta-galactosidase, which hydrolyze the lactose into glucose and galactose. But Amul already selling the lactose-free milk. This is the USC milk. They are adding that enzymes in the milk, keeping for another 48 hours. Then they are selling it. It is completely free of lactose. It is only glucose and galactose. So they can prefer this one.
Okay, just for information of audience, the college, the place where Dr. Subrato Hathi is working is one of the most reputed and oldest very sensitive technology colleges of our state. Previously, it was a part of Anand Agricultural University, but on constitution or formulation of Kamdenu University, all the 4 to 5 colleges of the state.
All the veterinary, dairy and fishery.
Yeah, that
are coming under animal science.
Okay, for his contribution, his paper has been selected for the award during the year 2021. So here, this is the second award for 2021, and I request Dr. Dhara Kami to felicitate Dr. Subrato for achieving this with the award, bag and certificate.
is Dr. Vimal Kumar Prajapati, sir, Navsari Agriculture University, Surat.
Doesn't change. Yes, good morning everyone. One of our over here. This is Dr. Vimal Prajapati here. I am presenting one of the paper which is published in one of the reputed journal in elsewhere, impacting something around 9.2. I know that I am standing between you and your lunch, so I'll keep my talk minimal and I'll rest of the talk in lesser than 15 minutes even. So first of all, I'd like to thank Department of Biosciences, this Vrinderma South Gujarat University, as well as wave of microbiologists who choose this paper and put up and for the wide publicity among you and create a wonderful awareness that this kind of activity is being conducted by them and published in one of the session in ongoing conference too. And I was also thankful to the GSPTM because I am seeing this is the only nurturing body in entire Gujarat. Since my UG career, I am seeing this particular body. They have supported a lot of researcher when they are pursuing their UG, PG as well as PhD, and they provide a wonderful support as well as their research career is in the budding stage. Now, let us go ahead. These are the some of the paper. I think Neelam and I share the same ancestral background since 2013-14. So these are some of the papers which has been published in the Frontiers Group of Journal in 2020 only. One of the paper is in scientific reports because I am not just working on just a metagenomic and genome content part. I have some little bit expertise in metagenomics. Apart from that, elaboration of those enzymes which are not cultivable, not available from the cultivable strain even. So this is one of the wonderful paper which is published in scientific report. But at present, the paper what I am talking about is biodegradable hydrogel. So I'm not going to touch the introduction part because hydrogel is very well known. But there are two kind of stuff what we can see. Hydrogel can be commercially which is available, which is of synthetic material. It could be from acrylamide and bisacrylamide mixture too. And some of the hydrogels which are naturally available. If you look at the fundamental theory behind this synthetic available and naturally available hydrogel, the moment the hydrogel start degrading, the monomeric part lead to some toxicity and which ultimately ruin the complete niche of a soil environment. So we are trying to focus on a certain hydrogel formulation which can be a naturally available polymer and can assimilate large volume of water or aqueous body, and it can be employed in number of ways. So these are the number of application of hydrogel. I am not going to touch more in detail, but yeah, this is a wonderful era. You can explore the hydrogel in different sector with the help of peptide, DN and PEG, polyethylene glycol. You can use those kind of polymer and formulate a hydrogel that could have a wonderful effect in medicinal science too. So these are the certain urban sectors which demand a great amount of water. But our theory is very much clear that we want to develop a hydrogel that can hold aqueous quantity in very large manner and subsequently release it in a slow manner, so that you can swell the hydrogel with the help of biofertilizer or maybe some nutrient metal which is required for the plant. So we have hypothesized the formulation of hydrogel, and these are the sector what we can apply where you don't need to water the plants every day. You can apply this particular hydrogel in open field terrace farming. You can go with the home ground garden, vertical farming, bare root dipping and hydro seedling. These are the certain area which can be taken care with the help of hydrogel. But what exactly this hydrogel is? So guar is naturally available plant material. This is one of the polymer, or it can be act as an backbone. We grafted this backbone with the help of methyl acrylate, MMA. This is a kind of a monomer which can be backbone on the guar gum with the help of initiator. So this potassium persulfate, which is called as an initiator, this is monomer, and this is a lactic acid which is a cross-linked polymer. So with these three different material we have formulated a hydrogel, and which is labeled as a guar gum grafted polymethyl acrylate cross-linked polylactic acid hydrogel. So these gel having a wonderful capacity, we have compared this particular gel with the naturally available gel too. So what we have done, so this is some theory which is already done in paper, but let me tell you again, yeah. So the component what I have told, that methyl acrylate, this is a monomer, potassium persulfate which is initiator, and polylactic acid, this is a cross-linker. So these three parameters are playing a very much important role to form a hydrogel. So we have taken these three different parameters. These are the sum of the range. And these data has been designed from the one factor at a time OFAT methodology, because we have used GORGAM and these all four different parameters in a different way using a OFAT methodology. And we choose that this is the range what we can use for the further designing of experiment. So this is a particular experiment which is called the response surface methodology using the central composite design. And this CCD design is worked on this wonderful theory where you can supply a range and CCD work and predict beyond the range value too. So here we have a coded value, and this is the -1, +1, -alpha and plus alpha point. So these are the beauty of this design, that it can provide you some prediction beyond the feeded value in the software. So the software seems to be like this, and it can give you an entire table which is written over here. These are the coded value, all cases, and here the actual value what we have fed to conduct the assay to form the hydrogen, and this is the swelling index. Okay, so here you see this is -alpha and plus alpha value. Here also the -alpha plus alpha value for the polylactic acid and potassium persulfate, because we narrow down these three components. This is initiator, this is cross-linker, and this is monomer. GORGAM concentration seems to be fixed in entire case of experiment. So we have a 20 different run. In every 20 run, we have 1 gram of GORGAM. So when we predicted the ANOVA, analysis of variance, using this design, the model found to be the significant one. You can see the methyl acrylate. This is also the significant model term. And here also the interaction between the component A and B. A seems to be methyl acrylate and polylactic acid is a B. So monomer and cross-linker both are playing a very much important role for the porosity formation in the hydrogen. So these two components quite playing a very much important role. You see the potassium persulfate. Potassium persulfate is just an initiator. So it can initiate the reaction so that you can have a free radical on OH group at the GORGAM gel. So you see the lake of fit found to be non-significant in any quadratic model. When you look at the quadratic model, non-significant lake of fit is mandatory. If it is a non-significant lake of fit, that means your data fits to the model in a very well manner, and so that you can go for the further designing and predictive model experiment. So we have this is the quadratic equation where Y stands for your response, which is nothing but a hydrogel swelling index. You can have A, which is a monomer, B, which is a cross-linker, and C is a initiator. So if you put the certain value over here, you can have a pre-predicted value of the design. So you can see after this designing, the validation can come with this particular graph. This is the contour plot and this is the response surface plot. Both plot reveal the same theory and same prediction, that if you take A and B, which is a monomer and the cross-linker at the lower level, they does not show any significant effect on the swelling indices. If you keep the monomer at a lower concentration and keep increasing the cross-linker, then also the swelling indices doesn't perform well. If you put the polylactic acid, which is a cross-linker, at the lower level and keep on increasing the methyl acrylate, which is a monomer, then also there is no significant effect on the swelling indices. But if you look at this particular portion when A and B both are at the higher order, you can see a wonderful effect on the swelling property. If you look at the another part where we try to see the interaction between the A and C, here A is again a monomer. We try to understand the interaction between the A and C. C is a initiator, which is potassium persulfate. So if both the component, when they are present at the lower level, they does not show any significant effect. But you look at clearly over here when APS present in the system at low level, and when you keep on increasing the monomer level, you see there is a sharp shoot up in the swelling index. So it was quite understood that you need to have a monomer and the cross-linker at a higher level, but this particular graph reveals that you should keep initiator at the lower level. And now the another index is to understand the interactive effect of B and C both. So here is a polylactic acid, which is a cross-linker, and another is the KPS, which is the potassium persulfate, which is the initiator in this particular hydrogel. So here also the same theory works. The KPS when present at the low level, and when you keep on increasing the polylactic acid level, you can see the sharp shoot up in the swelling property. But both at low level does not show any significant effect. So this graph and the previous graph both reveal that your initiator concentration should be low enough. Your monomer and the cross-linker, which is methyl acrylate and polylactic acid, should be high enough in the provided range so that you can have a perfect swelling index and you have a wonderful hydrogel. Now, when you check on the hydrogel, the swelling index of guargum grafted polymethyl acrylate cross-linked polylactic acid hydrogel. This is the hydrogel which is naturally available polymer we have used, and you can see the swelling index is 38.3, while you see the guargum hydrogel where polylactic acid is not there. The hydrogel got formed, but polylactic acid, which is a cross-linker, is missing in this gel. So you can see the swelling index is somewhat low enough, and we try to compare those commercially available hydrogel which is already been published using the guargum as a starting material. You have a monomer where methyl acrylate is being used. There are no reports available where polylactic acid used as a cross-linker. So we already filed the patent for the same. By the time our publication came up, now it's in somewhat controversy, but let us see if we got this particular as a patent event. So you see the polylactic acid, there is no report available in the database using it, and you can see the swelling indexes in the percentage. Yeah, this is the hydrogel what we have synthesized, and when it is available before the swelling, you can see just a 5 millimeter or lesser than that, and you are see here it's something around 15 millimeter. So 3 times swelling is happening in this hydrogel. So we have conducted one of the absorption study too, which can assimilate more amount of water compared to the acidic liquid and the ionized solution. As far as if you dip this particular gel in 0.9% NaCl, then NaCl creates some osmotic disturbance, so that the fluid cannot go inside the hydrogel. So this is the main cause where when hydrogel dipped into the 0.9% NaCl solution, we are unable to get the good amount of swelling. So now you see we have characterized, this is a different part that we have worked on this. This is a characterization part. In that particular case, we have used the FTIR analysis. You can see this particular first A represents the polylactic acid FTIR. This one is methyl acrylate FTIR, and this is a formed hydrogel. And this hydrogel is without lactic acid. You see, these all initial peak where here in this case you do not have, this is methyl acrylate, so there is no OH stretching over here. But you can see this OH stretching come to this, and this stretching will come over here when we form the gel. And this is a very prominent peak of carbonyl ion. Okay, so here this particular C picture reveals that our grafting and the cross-linking performed in a better way. This particular FTR reveals that. Now you see we have conducted another TGA study which revealed the component degradation part. So here you see every different molecule have been tested for the TGA analysis. In this first, this is a natural guargum. If you see, there are 3 different indices were observed in the temperature profiling, but if you look at over here, maximum degradation quite observed in the case of 362 temperature, which is revealing 63.43% around. If you look at this guargum hydrogel, where there is a grafting occur with the help of monomer, but there is no polylactic acid. You see, the tolerance of temperature gets up. Here 241 gets shoot up to the 250. If you compare this both TGA analysis with the formed hydrogel, you see there is a quite resistivity developed in case of grafted hydrogel with the help of monomer and polylactic acid both. So maximum degradation here you see, this is a first part always revealing some of the moisture and aqueous ion gets evaporated or degraded. Here this is the part where mainly the monomer and the cross-linkers are get detached. And this part where polyols or maybe some alcohol containing materials are getting degraded. We have subjected this hydrogel for the SAM analysis too. This is native guargum. You can see the there is no distinct shape and no uniform solution, no uniform suspension, no uniformity at all in this. While this is control guargum hydrogel where there is no polylactic acid. So what is the effect of polylactic acid to form the hydrogel? You can clearly see between the B and C. Here there is a microporous and megaporous both structure you can see over here, and there is a clear-cut margin so that this particular gel can absorb, assimilate more amount of aqueous liquid. It could be biofertilizer, it could be normal water, and delivered in a very fashionable manner so that the hydrogel where there is a picture of a water storage, you can apply this hydrogel. Yeah, so this is somewhat the conclusion, but this is the paper which is published in 2023, again in the same indices journal. The same gel has been subjected for the testing in pot study. So guargum grafted polymethyl acrylate cross-linked polylactic acid gel, hydrogel, had been used for the wheat study. So we have conducted this another study and we have already published this paper. And yeah, in the same, these are some of the more paper in genomics, and yeah, this is again, we have used the same methodology what I have adopted in hydrogel formation, that is on glutaminase enzyme using this Saccharomyces species. So that's all. Thank you.
Thank you so much. Very nice presentation. Any question? Okay. So I request Dr. Himanshu sir to felicitate Dr. Vimal Kumar Prajapati. Sir, your work is selected as a best research paper in the year 2022. Congratulations, sir.
We belong to the same department again.
The next awardee is Dr. Professor Devianiti Gray from Gujarat University. As she is not presently with us, she will deliver her talk through online mode. For the year 2022, Dr. Devianiti Gray is the awardee, and she shares this award with Dr. Vimal Kumar Prajapati for the year 2022.
હલો હા એટલે અમની કરશે હા 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 હા
Madam, you can start. Hello. Only madam, you can start your presentation. Am I audible to you?
Hello, good afternoon everyone. Hello, can you hear me?
Yes, yes, it is audible. You can start.
Yeah, on my behalf, my author, Dr. Avni Vaishnav will be presenting this presentation. So kindly unmute her. She has shared the screen. Please unmute Avni. Hello.
She's unmute only.
Avni, you can start presenting.
Avni. So there is some problem with the microphone, I think.
હા તમને અનમ્યુટ કર્યું છે
અનમ્યુટ કર્યું છે પણ અવાજ નથી આવતો. અવની મેડમ શેમાંથી કરે છે, મોબાઈલમાંથી કે
Hello.
લેપટોપમાં? હલો.
Huh. Hello.
હા.
Dr. Rajesh, there is some problem. She is talking, but I think.
राजेश, अभी वो अनम्यूट नहीं हुआ है, आप देखिए ना, देखिए म्यूट का ही सिंबल आ रहा है अवनी का. There is some problem, just have a look, because the symbol is showing mute for Oni.
Madam, now you can check.
Hello. હા, yes.
અવની મેડમ એમના ઘેર છે કે તમારી સાથે છે?
ના ના, એ એમના ઘરે છે.
એમને ફોન ઉપર પૂછી લો ને, કેમ કે અહીંયા તો અનમ્યુટ કરીએ છીએ, શું પ્રોબ્લેમ છે ખબર નથી પડતી.
So by the time, if Dr. Ashish Vardhane is ready, we can proceed with. Dr. Ashish Vardhane is from Gujarat Technological University, Ahmedabad. He has been selected for the award for the year 2023.
Thank you very much, VNSGU and the Web of Microbiologists for selecting our paper for this Web of Microbiologist Award. And thank you very much for inviting me here. Thanks to Rajesh. So my humble submission to the chair and co-chair is that it is a review paper basically. I submitted my research paper also, but luckily it is accepted. And there is a novel work that is on the lab technology, that is a unique technology. But it is the paper, and I will get to how the story is what Joe Rajesh Sante bola hai. So next please. So this is the paper which we published into the This is the paper which we published into the frontier in cellular and infection microbiology. The impact factor is around 5.7. Title is the role of nanocomposite against biofilm infections in the human. I am basically a plant biologist working on the citrus pathogen. In that I am working on the bacteria which is not cultured. Means it is very close to virus. Right? So, very happy to share you that this paper, if you see the statistics here, 2,677 times it is downloaded. Total views, 644 is the downloads, and 8 times it is cited, just 1 year back. And 2 news comes in like Twitter. So, then I introduced my team. Basically, it is a work and invitation got to the Anand Verma. He is a nanotechnologist from the central, it is from the CSI laboratory, that is a lead present in Nagpur. And I am basically from the Nagpur, which I did my PhD from ICR Central Citrus Research Institute Nagpur. So I work on the citrus viruses. Then Neena Dhawan is from the Delhi University. Neha is again from the Nagpur, but currently working in Faculty of Life Science in the Mysore University. Vijay is working on the tuberculosis, Sevaram Hospital, currently in the Parole. Anupama Murthy, she is my colleague at School of Applied Science and Technology, it is in GTU, and she is the key player in this paper. She done her PhD in AIDS and work on the human pathogen and cancer. Rashmi again is Rashmi working and postdoc in Brazil, and she is now the assistant professor in Delhi University. So this is our whole team. So how the story is started, I will tell you. This is the classic paper, comes in 2018. And this is the first report that we use nanomaterial along with the theme for the management of, I'm not saying the word control, for the management of the Candidatus liver excentricus. The bacteria which I am talking now, it is the bacteria till date we don't have any solution. And it is a major problem in a citrus which collapsed the complete University of Florida citrus orchard and US orchard, and in India it is a major pathogen. Still we don't have any solution. So this problem we started and we make the formulation to control this bacteria, and finally we are able to control this bacteria. This technology is already patented, and this news is comes in Times of India. So these are the 3 drivers behind this technology, and that time I am doing PhD in this process. So he is Dr. Sandra from University of Florida, a great nanotechnologist in the world. Then Dr. Ghosh is my PhD guy. He is a virologist, top 10 virologist in the world, and it's very simple guy, Ashwini Kumar Sharma, with I did my PhD work in IIT. So these are the great personalities lead to the major solution, and now it is under the ICR trial. Hopefully we will get this solution for again this factory. And for this I got the Young Scientist Award. You find that it's another news from the activity, and this is the photograph in our lab and PhD lab. But we got the award for this paper. The story started by once this paper we are getting a call from the entire world. How we can control this virus, and we have the now MOUs and working with IIT, University of Florida, and the Wilson now GPU, say the part of this one. So this paper is comprises with the how we can use nanocomposite, right? Nanoparticles everyone is using. So how nanocomposite we are using to control the human pathogens, because my team is specialized in medical microbiology, they got the invitation, and luckily due to the nanotechnology angle into the plant pathogen, I am a part of this paper. I am just co-authoring this paper. So nanocomposite is the multiphase stable fabric with one of the 3 dimensions that much smaller than 100 nanometers. We use some polymers on 3-dimensional structure which is in 100 nanometer in the range for the control of pathogen. And we can target all the view, this is a major view, and we collected the very large article and found that we can use nanocomposite against this kind of the diseases in humans. So biofilm, you all knows that is a very strong material and very few antibiotics are able to crack this barrier. For that, nanocomposite would be the good answer. What our survey is telling us that. So it will be work against both gram-positive and gram-negative bacteria, which are the human pathogens. And these are the chronic barcodes in the wound. It is also working very nicely. So what is this nanocomposites? So it is polymer-based, nanocomposites, and non-polymer based. These are the different classifications. I will share my entire this paper to the audience so they can reach out these entire things. So very different kind of this material and have a very good potential against the human pathogens. So how we can use this one for these various anti-paraffin biomolecules cases against herbal active compounds, stimulating agent. We mix this antimicrobial compound with this nanocomposite to get the good results. And so many researchers got a very good result from this. So these are the some evidences that we got from the SODS, these are the major pathogens, and these are the least of all red highlighted nanocomposites showing the excellent result and published in the good paper sources. Then, in a case of nanotoxicity, these are the major considerations. One is gram-positive, gram-negative also. And one concern in these one is that toxicity. So many people using the nanoparticles, I am agree with that. But what's about the toxicity we are generating? Recently, our paper is published in the biology elsewhere that we address this point. So many guys are using one. Today's solution is the next problem, right? So every research should be doing that method, and we highlighted it to the line. These articles just recently published in the elsewhere biology. So we are thinking that the green nanotechnology will be the good answer for this one. So audience may try with this one also. Then these are the for gram-negative bacteria also nanocomposites showing the very good results. We got the very good for Pseudomonas aeruginosa, which is the major nosocomial infection if you know. Those are the burn injury. This is the first organism who will attack. Then from the major pathogen which you say to pneumonia, bacterialis and typhus also showing the antibacterial properties for this. So in a conclusion, which bacteria? We can see that in conclusion, recent studies also observed that this molecule, that composite, consists of three phases, inhibited against the gram-negative bacteria E. coli and originosa. Then 70% activity is effective as compared to antibiotic alone. If you target the one antibiotic along with nano, it is 71%. And this is the, it has been observed in non-reactive gram-negative bacteria for this one in a biofilm also. And this is the same which I initially discussed. With this, so currently I'm working with the Rajesh also in another project. Similar kind of the team which currently we are working on natural farming and other projects also. The team is almost just my previous study, Dr. Neera is saying. We are working in a team and this is our team SAS. This logo indicates my entire GPU team. So it is Dr. Ghosh, BHO is the Vice Chancellor of AKS University, and Dr. Rashmi, which I showed you to the market. Still I am working in some project. My director, Dr. Vaibhav Chikti, my JRA, so we also published one poster in our present conference also on our natural farming project. But Ankit and Priyanka also here. So thank you very much for these sessions. This is my GPU and our school. We are happy to invite you there for the visit or any kind of a collaboration from your side. Thank you very much.
For the excellent work and presentation, Dr. Ashish Varkane is awarded for the Best Microbiologist Award 2023. I request Dr. Dhara Gandhi. Yes, we have some time with us, so we can have questions. We can have few questions.
Yeah. Yes, there is a mechanism. Yeah. So there is a very unique mechanism I mentioned to my papers also. So there is a composition of plant, a cell wall and a plasma mechanism, right? So it is working in that way. Excellent mechanism, sir. I will share with that in the very detail. Molecular level, very few papers we got, but on the data is now generated. Not, we're not issued. Thank you.
Nanoparticle, nanocomposite, these days running in front. So I hope there will be plenty of questions. So feel free to ask. If no question, we can move forward. I personally congratulate Dr. Ashish. As shown, you are a good researcher, but at the same time, you are a good orator also. You are good enough to express the things that you have done. So, I request Dr. Dhara Gamit to extend Dr. Ashish Wadhane for securing his award. Dr. Ashish is from Gujarat Technological University and has secured this award for the year 2023. Let us put our hands together. By the time Dr. Vishal Devara can come forward and move to his presentation. Thank you, Dhara.
So, good afternoon, everybody. So, I'm just we are just trying to just correlate with the microbiological concept only. So, Vibrio cholerae, it's like a older organism that we have already understood. But we are just skipping some of the important aspects of Vibrio cholerae, how they are just coming to the multi-drug resistance, which is right now we can say fascinating word that we are using for so many other research works, and we are supposed to identify so many different type of genes and other things only. But the understanding is that we have just came into the understanding of how this multi-drug resistance was acquired, particularly in cholera itself only. So we are starting with some introductory part only. Right now we are just in a search of that during this COVID epidemics only. We are the witnesses who basically identifies the actual what is epidemics and what are the peoples are basically died of due to this epidemics only. So before that we are moving to this topic only. We need to just understand how this cholera is basically killing so many people in the past only. So I would like to just explain some of this particular. Sorry, there is a mistake. So as we are just understanding that the cholera is basically giving us 7 different pandemics in past. And it is basically killing so many people. So if you are just coming to the first one, that is basically killing more than 1 lakh people. If you are counting, you are just comparing the population that is present into 1800 only. And if this disease can kill so many, theoretically we can say it is 1 lakh people has been died of this due to this epidemics, then the ratio is very high, which is basically observed currently we are comparing with COVID-19. Then still the number is very high. And along with that, it is basically giving the 7 different pandemics after the first pandemic was observed from India only. So that was the problem that we are facing. And still We are also identifying so many different type of cholera and then different strain, and that basically killing so many people of the death are basically observed from worldwide. And still in 2023, 2022-23 only, we are having so many different cases of cholera has been reported only. So in Gujarat only, we are supposed to have so many cases where that is basically observed from Kadi near to the Patan only, Patan district only, and along with that we are also getting some cases from Ahmedabad district only. So due to the contaminated water only, we are supposed to observe the presence of Vibrio cholerae, and how this can be initiated or how the number of cases has been increased, that we are going to understand only. Now, if we are comparing the number of cases worldwide that is observed from 2000 to 2021 or 2021 only, we can observe that a very huge number of cases are observed after 2016 only. So after this 2016 to 2022 only, we are having a very huge number of expansion in cases of cholera was reported, and that was a tremendous understanding that we need to just focus on which are the neglected diseases that we are infectious neglected diseases which are basically associated with the microbiological aspects, and that must be understood and that must be explored what are some of the other reasons, and that's why we are just focusing on this study only. So the sample was collected from a patient, that is female patient, that is having the age of 26 only. The stool sample was totally the rice water. So whatever the stool sample, it is only having a white colored water is only, or water-like structure only. And from that only we are supposed to identify the actual consideration that it should be either cholera or maybe some other disease only. So that was the consideration, and from that sample we are supposed to grow this organism on a laboratory media only. So initially that was concerned that we have explained analyze so many patients and belong that all the patients we are identifying one is exactly we can say it is a cholera Vibrio cholerae, and we are supposed to go for sequencing of this particular organism only. So if you are considering a workflow, the first part is basically isolation and antibiotic susceptibility. So that is most probably we are doing as a microbiologist. So this is our initial part, and we are supposed to identify some antibiotic resistance toward the particular different type of antibiotics that we are using for microbiological assay only. After that only we have just gone for the first step is only restricted to the microbiologist. So it is our core domain, and we are more focusing on identifying some of the specific type of antibiotic resistance organisms. And later on extraction of a genome DNA, then whole genome sequencing with the nanopore technology, which we are using for right now for so many other genome sequencing as well. Then MLST based and type strain based identification. Later on genome annotation, detection of MGE, and later on identification of resistant genes only. So initially, if you are just gone for the antibiotic susceptibility, at the same time we are just identifying the organism is basically resistance toward the amikacin, gentamicin, this trimoxazole, and so many other type of antibiotics. But this is not a concern. The concern is that the organism is capable of retaining the susceptibility. So it is basically, we can say, susceptible to the generally tetracycline, chloraphenol, and trimethoprim only. So we can treat the person with this type of antibiotic. So that is the not concern. But this was the initial understanding where we are just keeping some of the important aspects of MDR that is basically available, that is prevailing in so many different type of organisms that we are not able to identify with the help of analyze with the help of genome sequencing only. So for that only, we have just gone for the detection of this organism based on the 16S RNA based sequencing only. So initially we came to know that it is exactly the same strain that is near to the 80cc strain only, and we are just identifying this exactly the Vibrio cholerae only. Later on, based on the MLST profile, so MLST is basically applicable for the marker-based detection of any particular antibiotic resistance organism. So based on that MLST profile, we have also verified that it is exactly the Vibrio cholerae. So that was the initial understanding that we came to know that it is just a Vibrio cholerae, and we have to just analyze the organism based on the whatever Vibrio cholerae and how the genome sequence of this organism was. Can be analyzed, and which we are trying to identify some of the important aspect of this Vibrio cholerae only. But after that initial understanding only, the genome annotation, I was a little bit surprised that most of the cases we have just learned that the prokaryotic organisms are supposed to have the single chromosomal structure only. But after this analysis only, I just came to know that a Vibrio cholerae is having two separate circular DNAs there, and you can say it is a two different chromosomes are present in Vibrio cholerae only. So at the initial stage only, I was just a little bit curious about that, how this organism is basically how the two chromosomes and how it can be replicated only. So that was a general concept only, but out of this analysis only, we came to know that there are so many hypothetical proteins are still available in the well-known organisms like Vibrio cholerae. So we can observe that more than 800 different proteins are still remains as the hypothetical proteins, and that's why it is difficult. We need to just strengthening our methods to analyze these hypothetical different proteins, and we are supposed to identify some of the methods to evaluate or annotate this type of hypothetical proteins as well. Another thing is that we have just worked for the another protein-based assay, protein-based annotation only, but still we are just trying to understand some of the specific pathways and some of the specific type of susceptibility studies are required. So out of that only we have just analyzed all the different more than 1500 pathways we have analyzed, and out of that only we have identified some of the specific antibiotic resistance containing pathways are basically examined, and we are surprisingly identified some of these pathways that may be having some resistance toward the drugs which are basically not meant for the treatment of the cholera only, but the organisms are basically having they have developed a resistance toward the different antibiotics or different chemical structures that basically used for the treatment of cancer, then cancer immunosuppression and other type of applications which are the people are using for the particularly for treatment of cancer and other related diseases. Along with that, we have also identified some of the specific pathways that are associated with the viral antibiotic viral susceptibility or the viral resistance toward the different type of antibiotics. So that was the initial consideration where we are just understanding, and we just interested more to analyze this particular this organism in very depth only, because it is initially we are just came into the understanding that it is just a Vibrio cholerae, but later on after these results we are getting, we are just focusing on more towards the different antibiotic resistance that was acquired actually it is present in the genome sequence of that organism, but still we are not able to identify with the help of traditional methods that we are using for microbiological assay and related things only. So surprisingly, during the antibiotic resistance, initiation of this antibiotic resistance, we are successfully identified that this organism is basically resistant towards 63 different antibiotics. So it is a little bit difficult. So initially it was just understanding that we are identifying 4 or 5 normally the traditional whatever we are using antibiotics we are using for the antibiotic susceptibility assay only. But out of this analysis only we came to know that approximately 63 different antibiotic resistance was acquired in this strain only, the same strain only. And after analyzing with the different approaches only, we are came to know that as it is more than 100 different genes are basically have present that may be having some importance in antibiotic resistance only. So that was the case we are just focusing more towards the AMR related things only, or the multi-drug resistance in this particular the same strain that we have isolated from the patients only. So the concept was that we have just identified the specific genes that is associated with the resistance toward the specific chloramphenicol and whatever the other type of antibiotic that we are using for the treatment of so many other diseases as well. But this organism was surprisingly resistant toward this all the antibiotics, and that was actually we can say it is basically the resistance is present on in the genome only, but it is basically not expressed at up to the certain level. So we are as a practical value we are not able to identify any particular type of resistance, but it is already present in the genome only. So sometimes at the stage of epidemics only, this type of genes are basically expressed into certain level, and this will also causing a several death. And we are also observing similar approaches to the COVID-19 only. So we are having a multiple type of variants are basically observed, though the structure is remains as the same one, but still we are getting a similar type of infection that we are observed from different strains as well. So that was an understanding of a different antibiotic resistance genes that was observed for this the similar strain only. So it is not only restricted to the particularly the antibiotics only, but it is also observed that the antibiotic effects are there, antibiotic inactivation steps are basically present, the gene related to the antibiotic inactivation. So whatever the treatment we are giving, automatically it basically inactivates the antibiotic in a particular organism only, and that causing the antibiotic what we are using, it may be considered as a non-functional to treat this type of organism only. So that was the initial identification for different type of antibiotic resistance. Not only this restricted to the antibiotic, but is also we have also identified some other type of approaches that is associated with the multi-drug resistance, or that can enhance the multi-drug resistance in this type of organisms only. So after that only we came up to the understanding that this is only the it is not a possibility that the single organisms can cause the changes in the genome only. So we have just gone for the identification of a general concept, that is lateral gene transfer only, or in other sense we can say it is a horizontal gene transfer only. So we are fortunate that we have identified some of the specific segment of the genome only, that basically not exactly from the actual from the Vibrio cholerae, but it is basically coming from any other organisms only. And that was the consideration where we are traced out a particularly gene that is not exactly from the Vibrio cholerae, but it is exactly from any other related organisms that may be having some that may be having similar genes, and these genes are basically acquired from a nearest organism that is residing in that environment only. So we are successfully identified that approximately this afflamycin resistance was observed from this SNP based detection. This is not exactly from the Vibrio cholerae only, that is afflamycin resistance. Along with that, we are also identified some of the specific type of biovars, that is E1 biovars. So you might be understanding that Vibrio cholerae is basically have more than 200 different serovars. So is it the same organisms, but based on the serological structure only, there are 200 different serological serovars are basically observed for Vibrio cholerae, and this was one of the part that we have acquired from similar type of one of the biovar, that is E1 biovar, 01 biovar E1 only, and after that only Yersinia, then Legionella, Haemophilus influenza, and along with that Neisseria meningitis. So from these organisms only we are coming to the understanding these genes are basically coming from actually from another organism which is not exactly identified in a Vibrio cholerae, but we are successfully traced down this of the this specific type of gene that is present in the genome of this Vibrio cholerae only. Then we are just understanding that what are the other aspects of this integrative or conjugative elements which are basically similar function that is observed. So we are also traced down some of the specific segments from this genome only, and we have successfully identified from the different nearest strain it was basically gets acquired the similar genes or similar fragments of a DNA that is acquired from a near the similar strain or near to this Vibrio cholerae strain only. So we have just traced down a few of the particular things only, and we are just identified amongst the 198 ORF sequences, 28 are basically found to be similar that related to the species from a database only, and rest of the other sequences or the ORF sequences are basically not from the database purpose only, and that was evolved beyond the we can say with the diversity and the what are the different genes basically are required. So based on that only this ORFs are basically observed, which is not exactly available in the database only. Actually, we can say it is a novel type of segments are identified. Along with that, the Vibrio cholerae is also identified to have the fast treatment that we are using for the treatment of this type of organisms only. So the fast treatment is basically useful for so many other type of microorganisms that we are using in medical sciences as well. But still, we have also traced down the identification of this profast detection. So the profast is basically the sequence that is not exactly from an organism only, but it is exactly from a viral particle only, and due to the time and other constraint only, it is just acquired inside the genome only. So we have just traced down 4 different type of phages that has been detected, and you can just observe the percentage score, that is percentage identity, that is the one is basically the phase CTX only. So that is used for cholera toxin phase only. So CTX phase is basically totally 100% phase was integrated in the same genome only. So it is also acquired the gene from the whole genome from the CTX phase only. Along with that, we have also traced down some of the specific type of Escherichia coli, Pseudomonas type of other phases, and along with the fourth one, that is also the Escherichia coli only. So we can say that it is approximately more than 4 phages are basically present in the same genome of a single organism only. So now this strategy what we are using for the treatment of this diseases is no longer is effective one with regard to the development of this type of antibiotic resistance or the MDR related strains only. So this was the cases where we have traced down so many other features which are basically not exactly from a Vibrio cholerae only, but we are still identifying actual fundamental aspects of this different type of gene that is basically acquired from other environmental factors or other related organism that is basically grown near to the this organism only. So this was our study only, and After that only, we are just understanding that we have to go for the analyzing the whole genome analysis based on the what are the challenges we are observed. So you can we are just trying to compare 20 different type of well-known genomes we have traced down. We have analyzed the 20 different genomes from a same organism, that is Vibrio cholerae. Along with that, there are so many other type of MDR drugs we have taken for the analysis only. But after that only, we can just observe that BC1, which was our strain, it is totally different from other organisms, which are basically the same strain, that is Vibrio cholerae, but still we are getting very huge divergence are observed in this BC1, and that was our breakthrough for this identification of this strain that may be considered as an MDR strain only. So this was our outcome only, and we are just coming to the understanding that this study was the study was initiated with only the concept of identifying and a single whole genome of to have one paper only. But after this analysis only, we came to know that this paper is not only restricted to the genome paper only, but it is exactly the MDR paper only, and we have traced down all the different aspects of what are the possibilities for related to the antibiotic resistance identified, and we have successfully identified all the aspects of this antibiotic resistance in a single Vibrio cholerae, which is, we can say, it is right now it is a neglected organism that we are identifying. We are not considering the Vibrio cholerae as a disease that is basically causing so many deaths only. Amongst the team only, I am the youngest person, and the rest of the other four collaborators are basically present in this same room only. So the rest is basically have expertise in medical microbiology. Rajesh Patel sir, Rajesh Chaudhary sir, and rest of the two others are basically from Taiwan University. So these are the collaborating team. And so surprisingly, we can say that we don't have the single rupees grant, and we have just done for our interest only to elucidate the information regarding this MDR strain and identification of a different strain, that is different genes that is basically acquired from other organisms only. So this is, we can say, it is just an integrative. So as Singh sir has already explained, that we have to just expand our knowledge to the integrative approach only, and based on our understanding only, we are the people. Basically, some of our is basically from a microbiologist only. I'm also the microbiologist. So due to the skill set and other part only, we are just trying to integrate a genome analysis and other aspects of the microbiology to elucidate the knowledge that is basically residing inside the genome only. So that was the whole task we have done for this paper. So this is only restricted to this paper only. So thank you.
Any question?
Sir, initially we have traced down the whole we can say hospital for identification of cholera only, but the most of the cases that we are acquired are basically the susceptible to the particular antibiotics, and we are not considering those samples. For this analysis only, we are just came up with a single organism that may be having some importance in MDR only, so we have just restricted our study to the single organism only.
So this study was done on single organism.
Sir.
Is there any basic drugs like ciprofloxacin, levofloxacin, etc.?
Sir, initially it was done in this practical way only. So from initial antibiotic assay only, they have done this step for the identification of any similar thing only.
And what was the duration of study?
It is actually in 2020 to 2021 only. So the sample was collected during this COVID time only. So still we are getting these results only.
Usually we find mostly the Vibrio cholerae is susceptible to most of the antibiotics.
Yes, sir.
But this particular organism is find this status.
Yes, sir.
Alarming.
And sir, we are tracing after this study only, we came to know that the MDR was not only the concern, but we have to more focus on the Vibrio cholerae related diseases only. So you might be surprising within after this 2020 to 23 only, there are lots of cases of Vibrio cholerae was evaluated, and we are facing out some of the other organisms related to the Vibrio cholerae. So that was the concern. We are skipping some of the information which is basically present in the genome, but still we are not able to understand due to the not carrying out any genome analysis. So that was our
One more thing was there, like horizontal transfer.
Yeah.
Detected.
Yes, sir.
Between Neisseria and the other organisms.
Yes, sir.
It was also like Neisseria is very uncommon in our region.
Yes, sir.
Still the transfer was detected.
Yes.
Something
Alarming one.
considered.
Yes, sir, definitely, sir.
One more thing, the viral transmission of
CTX.
yeah,
Yeah.
it was particularly for the toxin
Toxin.
produced by that was also very important part of it. So very good.
Thank you, sir. Thank you, sir.
Thank you so much. No question? Okay. So, I request Dr. Himanshu sir to facilitate Dr. Vishal Mewada. And congratulations as your work is selected as the best research paper in the year 2023.
Hello.
Yes. Madam, now it is
Hello, am I audible?
Yes, madam. We are audible. So
Okay.
we are sharing the presentation. Wait for a moment. Madam, you can start.
Okay, thank you so much, sir. Well, good afternoon to everyone and myself, Avni Vaishnav. This is the paper which is very much dear to us because it got selected in one go after answering few queries which were taken up by the reviewer. May we have the next slide, please? Well, it is published in Food Sciences, Food Biosciences in year 2022, the impact factor being 5.2, citation score 5.6, and we have received citation in 6 different research articles. Next slide. So this is the graphical abstract of what a paper looks like. I'm sure it's very clear what we have aimed to do. Next slide, please. So we need to know what exopolysaccharides are. They are secondary metabolites. Of course, microbes are one such entities which produce them, but apart from them, it's a plant and animal which also produces them, making use of carbon as a source. But out of all of these, the microbial exopolysaccharides are considered to be most stable. They are mainly the chain of monosaccharides and may include non-carbohydrate constituents like acetate, pyruvate, succinate and phosphate. They are produced by microbes both intracellularly and extracellularly. Now, these have a possible alternative to various chemical polymers because of their biodegradability, biocompatibility, and enhanced physical and biological properties. May we have the next slide, please? And it is also capable of producing physicochemical properties, and when it comes to human application, they are edible as well as non-toxic to both the environment as well as the people who is consuming them. Next slide. So looking into all these are the possible areas where EPS have been or are being used. First is biotechnology, medicine, cosmetic, pharmaceuticals, food, environmental, and so on. Now, industrial production of EPS requires enormous energy in form of carbon source, and this makes the process very expensive. Entire cost, 70% goes into the into the expenditure of the carbon source. So it's very essential that we need to know or we need to find an alternative carbon source for it. However, there are various carbon source, cheaper carbon source which are available, but it's not possible that every time we get enhanced EPS production. So we targeted to the agro waste, particularly the food waste, which is produced by vegetable and food processing industries, cafeterias and fruit juice vendors, which can be an excellent cheap source of carbon. These sectors generate large quantities of waste in form of pulp, peels and seeds. Now such waste has various advantages like, first of all, they are non-toxic, they are biocompatible, they are reasonably cheap, and at the all, the conversion rate of such substrate by microbes is up to 70%. Microorganisms, particularly bacteria, can easily biochemically digest these constituents like carbon, nitrogen, cellulose, hemicellulose, lignin, vitamins, ash contents, which are present in the fruit waste. So it's very essential that we design a medium containing this waste, which will not only make the process cheap, but it also make the recovery and purification of EPS very simpler. So we isolated a bacteria named Xanthomonas campestris from rotten orange. Now we know that microorganism itself has a spoilage activity. And they mainly cause the spoilage of the fruits, even if they are stored or during the transportation, because they provide very high or large water content, and at the same time carbon and nitrogen which are naturally present into them. So Xanthomonas campestris was isolated on glucose containing media. Along with it, the yeast extract agar was plated. Now, it was very essential to know the EPS production potential of these isolated Xanthomonas. So first we made use of EPS production medium, making use of EPS broth. And after 120 hours of incubation, we came to know that our organism is capable of producing only 3.4 grams per liter of EPS. So it was very essential that we optimize it. Can we have a next slide? Okay, so we went for optimization, making use of one variable at a time. And at that time, we came to know that there were three factors which were having interactive effect on the production. So the response says that the optimized medium, definitely we lowered the concentration of yeast extract from the original medium. We completely omitted L-cysteine from the medium. The concentration of acetate went up down to 50% than the original medium. And above all, we replaced sucrose with glucose. And the production was enhanced to 9.6 grams per liter, which was very remarkable achievement from our lab. Next slide. However, the aim was to replace the glucose with the naturally available carbon source, for which we targeted the mixed fruit waste. So there are various methods by which the extraction of the carbon source can be done, but we mainly preferred the extraction with a simple method where sterile distilled water with different pH 2, 5, 7, 8, 8 were taken, and the sets were then subjected to incubation at room temperature, where we were capable of extracting up to 9.4 grams % of total sugar. Next slide. So this is the formulation of the medium, where you can see that in several formulations salts were used, in several formulation casein hydrolysate along with yeast extract were used, in some only casein and in some only yeast. Next slide. So this table straightforwardly states that there is low production when only the extract is used. So this is directed that extract is not enough to supply all the nutrients which are essential for the growth and production of EPS. There would be slight increase in the next three formulation, but at the end we were capable of adding or getting 11.1 grams per liter. So it was very essential. Next slide. that statistical method, particularly central composite design using response surface methodology, will be adopted, where various levels of casein hydrolysate, yeast extract, and sodium acetate were studied, making use of carbon source as a mixed fruit waste containing 8 gram percentage of the carbon content. Next slide. We were able to get 20 runs, out of which 6 repetitions and 14 were unique combination. Now this graph mainly states that higher concentration of EPS are obtained at decreased amount of yeast extract, and the positive influence of increasing concentration of sodium acetate and casein hydrolysis was observed on the EPS production. And if you go to the next slide again, you will be able to see that the type of the model is quadratic, and it clearly states that nitrogen particularly is not required for the production as it mainly enhances the growth and enhances the production. They also enhance the cell maintenance and enzyme production that play an essential role in the synthesis of EPS. So it was very much essential that we go for a large scale production where scale-up studies were carried out with 5 liter optimized EPS medium and formulated medium in 10 liter capacity Alvin-Meyer flask and 10 liter capacity fermenter simultaneously. The EPS production in the fermenter with the formulated media was 21.10 grams per liter, that too after 40 hours, 40 hours of incubation. Whereas on shake flask study, it was only 14.45 grams per liter after 100 hours. This was a remarkable observation which we got. In comparison to optimized EPS medium, it was observed that in fermenter, after 60 hours of incubation, the production started getting less, and however, highest was attained at 12.95, and in shake flask, after 100 hours, it was 7.60. Next slide. So, comparing the folds of increase, you can clearly state that it comes down to 2.8 fold or higher fold in comparison to the optimized media which is used in fermenter, and in comparison to the formulated media which we had formulated earlier prior to optimization. Next slide. The fermentation study or the fermenter study states that there is 1.6 fold enhancement in the production. So all I can say is an optimized culture medium significantly influences the commercial production of EPS because it guarantees the required nutrients in suitable forms and at a concentration that is not inhibitory to the microorganism. Carbon is a vital component of the cellular constituents which plays a vital part in the metabolic activity which enables the cells to grow. Considering that there are numerous cheaper carbon sources that are efficiently utilized by microorganisms, they can be screened to make the production process very cost effective. Mixed fruit waste is one such alternative as a carbohydrate source for the EPS production. Next slide please. So all I can conclude is the process is quite effective and cost effective. There was increase in production in shorter period of time where there was overall total enhancement in EPS production to 6.2 fold. That is, we started off from 3.4 grams and we ended up getting 21.1 grams per liter of the EPS. There was absence of L-cysteine, 50% decrease in concentration of sodium acetate, which enhanced to the good production of EPS. I would like to thank my guide, Professor Dr. Shailesh R. Dave, for always encouraging me. Dr. Devyani Tipre, without her, this presentation was not possible. She is the one who initiated the entire thing. The two co-authors, Dr. Manoj and Dr. Kinjal, for always helping me with the write-ups and the practicals. And Dr. Sudeshna Menon from Xavier's College, who is my current employer. Thank you.
So thank you, madam.
Thank you so much, sir, for all your help.
And if you'll be coming to Ahmedabad or if you're coming to Surat, you can take your award in person. So right now,
thank you so much.
right now we can just send the virtual congratulations. So
sir, getting accepted is itself a big reward for all of us. Thank you so much, sir.
Thank you.
Dr. Rajesh? Hello?
Yes, madam.
Yeah, thank you very much. Thank you. Thank you.
Okay, thank you. So with this, we are coming to end of the Web of Microbiology session. So Web of Microbiology, in introduction only, we have told that that is an organization where we can just have the microbiologists or the person who are coming from the other field and who are working in the microbiology. So you can access the other detail on this Facebook page. So at least you can have the snapshot, and if you are interested, you can join Facebook, and maybe in the next award you can be a participant and also winner for that. All the papers which are awarded will be giving the digital certificate to all the winners, because I think in all paper so many co-authors are there. So instead of giving a single one certificate, we'll be just supplying the certificate in a digital form where the original author as per the paper would be mentioned. So each paper author can have the same kind of the usage of that certificate. So as we are running late and in between we have to take one lecture from the next session, so I will ask Anjana for further instruction regarding the next session in between.
There is a changes in session. Actually, we had a session after lunch break, but right now we are continuing with this session of 1:30. That is keynote speaker of the PIMLABAS. For this session, I would like to request chairperson of that session, Dr. Pragnesh Bua. He is working in the Department of Microbiology at SMC Medical College. He did his master's in MS University and PhD in the MS University. He got a research award from the USA and the UK. Along with, he got a Dr. Jivraj Mehta Award from the Health Service by the Governor of Gujarat. He has given his expertise as a guest faculty in many of the workshops and training. He is working as an examiner and chairman in many examinations body of MBBS, MSc MLT, PGD MLT, and many of the courses related to the medical science. We welcome you, sir, on this occasion. Our another chairperson is Dr. Jagruti Barot, Assistant Professor in Zoology, Department of Bioscience, VNSGU. She did her MSc and PhD from VNSGU South Gujarat University. She has completed a NET qualification examination from Life Science. Her major expertise in zoology subject. She published more than 12 peer-reviewed papers. Under her guidance, 2 students are currently working as MPhil and 4 students are currently working for their PhD degree. We welcome you both of the person for the next session. Over to you, sir.
Hello. Hi, everyone. Should I start?
Our next speaker, Dr. Bimla Pass is online and
Okay. Good afternoon, everyone. So first of all, I have to apologize for all of you that I'm not very well with my throat, so you can hear that my voice is limited today. But anyway, I will do my best to give my talk, which is about. Let me share my screen. So here is my talk today. I'm going to show you different mathematics approaches that you can use for research on antimicrobial resistance and also infectious diseases. So I'm a senior researcher from a technical university of Denmark, of course in Denmark, and we have been dealing with research a lot on both AMR and infectious diseases, okay? Let me make sure that, okay. So before I jump into all the content of my talk. I normally like to show this book. It's one of the books that I read. So there's nothing much about the book that related to my talk today, but I just like the introduction of this book, that the introduction of this book is, they said, throughout the history of humankind, we have been fighting with these three things. First, we're fighting to have enough food to eat, fighting, literally fighting in war, and above all, fighting with infectious diseases. This is the thing that we have been fighting a lot. I'm sorry, you call me?
Excuse me, madam, your PPT is not visible. Please share your screen first. PPT is not visible. Have you started PPT or not, madam?
Oh, okay. I thought I shared screen already once, so maybe if... Now you see my screen?
Now it is visible. Just go to full screen mode, madam.
Yes. I thought I did it, so anyway.
No problem. Okay, now it is fine.
Yes, let's continue.
Okay, you can continue.
That's what I said.
Sorry for
this is the book that I talk about, and there's three things that humans fight throughout the history of humankind, like fighting enough food to eat, really fighting in war, and infectious diseases. Above all of this, the infectious diseases kill the most. Just one example, in 14th century, the Black Death that caused by bacterial Yersinia pestis that wiped out almost half of European population. Just one single infectious disease. And not talking about that we just saw from a few years ago with COVID-19, but we never had anything that killed us, half of population, just like in Black Death before. And that's because we have advanced in microbiology, advanced in epidemiology. And one of the things is that we have advanced in terms of sequencing technology. And that sequencing technology helps us to cope with infectious diseases. For example, a few weeks after the first case of COVID-19 in China, the first genome of SARS-CoV-2 or COVID-19 has been released. And since that, the development of the vaccine has started. And then also the investigation of variants development of COVID-19 has started. And all of this is because of the sequencing technology, because of the bioinformatics tools and approaches that help us to analyze inside the DNA or RNA sequences of those infectious diseases. And that bring us to the point that this is exactly why I want to talk about applying these bioinformatics with both AMR and infectious diseases. So I already mentioned one of the science that deal with infectious diseases is called epidemiology, which is the science that studies pattern, causes, and affect health disease condition in a defined population. So basically, when you're dealing with infectious diseases in epidemiology, we want to know four basic questions. First, what is it? What is the pathogen species that you are dealing with that causing diseases in the population? So that's the first thing you need to know. What is it? Has it been seen before? So it's just something that recently emerged, or it's something that already emerged a few years ago and come back? How can we fight it? How can we treat the patient? So that, like, what drugs that we can use, for example. Lastly, if the strains that we are dealing with or we are suspected, is it part of the outbreak or not? So this is like a basic question that you want to answer when you start dealing with infectious diseases. And this is what you normally do, right? You want to know what is it. You do gram straining, you do culturing and gram straining, you do multitask to know species. You want to know how can we fight it, what drug that you can use. You test what we call susceptibility test to see if it's resistant to antibiotics or not. And if you want to know further on, more and more things that you want to know from the infectious agent, my my point is, one thing that you want to know from infectious disease, you need one dedicated experiment. If you want to know 10 different things, you need 10 different experiments. And if you deal with 100 strands, you top it up. How many experiments that you have to be doing? But if you have what we call sequencing technology, so once you already cultivate, you got the pure culture, the single isolation of the bacteria or virus, you extract all the genetic materials, which is DNA, and then you sequence their DNA. Everything that you want to know, almost everything that you want to know. What is it? How can we fight it? Is it part of the outbreak or not? You can know by their genetic information, by their DNA information. So if you look at DNA information, you should see it as information. It is information, and it's a language that is in all the, it's a universal language because it's in every organism. And since it is information, it is language, to understand what is inside, what the meaning of that language, you need an interpreter. So I would say the bioinformatics tools is like an interpreter that interpret the meaning from the DNA information for you to understand and for you to deal with infectious diseases. Okay, so let's get through each of the bioinformatic tools that I will show you today to answer some of the basic questions that you deal with infectious diseases. First, an important question: how can we fight with it? How can we kill this bacteria? What drug that we can use? Of course, we want to test if the bacteria resistant to antibiotics, right? So how can you do with bioinformatics, with DNA? So actually, you can, there are numbers, when I say number, like multiple thousands of known resistant genes. So these genes is the gene that confer to be resistant to a certain drug or the certain class of antibiotics, okay? So these genes that we already know, we have them in the database. Basically, it's just a database containing sequences of genes that confer resistance to antibiotics, okay? So when you have these genes, so then it's quite easy. You use what we call alignment tool. So if you, maybe you heard about BLAST. So BLAST is one of the alignment tool that compare between DNA sequences and a sequence of genes. So once you have your unknown sequence, that would be a sequence of a bacteria. So you put that genome or sequence of that bacteria and search or do alignment between the genome of unknown bacteria with every genes that we know that resistant to antibiotics. And if any genes that confer resistance similar to the genomes or the sequence of your bacteria, then your bacteria could be able to resist to that drug or that class of antibiotics. Okay, let me show you this into action. So this principle, we have this in the tool that we call ResFinder, so resistant finder, for example. So, and this tool is publicly available, freely available. So we have both web-based version, which you can just use it without any installation, without any, mathematics or computational background to be able to use it. And we also have the command line version that you can install on your own computer or your own server, and it's require you a little bit more of the computational skill or mathematics skill to do that. But this is just for everyone, microbiologists, medical doctors, everyone that want to know if the bacteria that you have and you sequence resistant to antibiotics or not. So you basically can go to this website and then you choose what you call mechanism that you want to search for antibiotics resistance. So this is the mechanism that you already know, or I already show you, that having the entire resistant genes, and then you are resistant to the antibiotic. Sometimes bacteria doesn't have the resistant genes, but it's still resistant because it has another mechanism that is called chromosomal point mutation. So it doesn't have the antibiotic resistant genes, but it has one single mutation in particular gene that is not antibiotic resistant gene, and it makes them capable to resist to antibiotics. Okay, and I need to be sorry. I need to pause for a few seconds because I need to get something from my notes. I will come back in just a second. Okay. Okay, now I'm ready and I'm gonna share my screen once more time. Yep, let's do it. Okay, so that's the two mechanisms that you can search for antibiotics from the bacterial genomes. Then I normally chose both of them, and that's very important because if you miss one of these, especially, for example, the Campylobacter jejuni. Campylobacter jejuni recently resistant to quinolone resistance, and many of them, at least in European Campylobacter, they don't have the genes, but they have mutations in the other genes. So if you don't check for the other mechanism, the point mutation, you might miss interpretation from being resistant, and you conclude as being susceptible just because you didn't check for point mutation. So what next? Then if you chose for point mutation, you need to choose for what species, because the point mutation framework on what position, on what gene, is very unique for each of the species. And so far, we don't have point mutation mechanism that we know for every species. It's just some 10 or 15 different species that we know. And then you submit your genome over here, down here, just one genome at a time. And here is the result. The first result is from the chromosomal point mutation. And the genome that I tested here is E. coli. And this is not the result from the antibiotic resistant genes. This is the result from point mutation. And you can see that the JRSA, which is not antibiotic resistant, but this bacteria has a mutation changing from amino acid S to L at the position 83, and it makes this bacteria resistant to quinolone. The other example, this is not even a gene, this is a promoter in front of the gene. It's called MC promoter. In E. coli, if you have MC promoter changing from amino acid C to T in this position, the E. coli can resistant to beta-lactam. And here is a result for actual AMR genes. And you can see, for example, blast CTX-M15 that causing beta-lactam, for example. So this is a very simple way of using bioinformatic tool to identify antibiotic resistance through bacterial genome. Another example that I want to bring you in, this is one of the papers some years ago. You can see it quite a long time ago in 2015. So I bring this paper because I want to show you how efficient of having the genomic data available of your bacteria. So around late 2015, like December 2015, there was a gene called MCR1, you can see here. MCR1 is the gene that confers resistance to colistin. And colistin is the last resource of gram-negative, the last resource of antibiotic for gram-negative, meaning that, so if a gram-negative bacteria resistant to everything, we still have colistin. And now we saw that they started to resist to the last drug that we have. And that's very alert things that all the people working in public sector, they need to look into this. So we took this MCR1 gene, put in our REST database, and screen 3,000 of previously sequenced E. coli and Salmonella in our database within less than an hour. We know that we only have 6 of our E. coli containing these dangerous genes that causing colistin resistance. And that bacteria didn't come from Denmark, it actually came from the other country. So my point is, if you don't have this whole genome sequencing data of these 3,000 genomes, how long would it take for you to do susceptibility tests, either MIC or this diffusion of these 3,000 strands in the lab? That would be nearly impossible in a short term. And we did it in less than an hour, and this paper published in a few days. Okay, so this shows you a potential of having routinely sequence of whole genome sequencing of bacterial genomes. Okay, now I'm still with the antibiotic resistance, but now I want to move a little bit further on. So this is not just what you call just only a single bacteria that we identify AMR. This is just in the community. So how can we actually survey of the antibiotic resistant abundance in the community, in the world? So how can we do that? What sample that we should use to represent community? So we think about why not taking, sewage or wastewater that coming out from different community, different city around the world. So we actually took sewage sample from different parts of the world, different cities of the world. We started in 2016, and we still did that until 2020. So once you have this sewage or wastewater sample around the city of the world, how can you qualify antibiotic genes from that water sample? So this one is not a simple like whole genome sequencing anymore, because in whole genome sequencing, you need to purify the strand. You need to cultivate a single isolate. In wastewater, you don't cultivate a single isolate. You take the actual raw sample. In this case, it's a wastewater sample or water sample. You extract all the DNA from the water sample, and then you analyze, you sequence that DNA, and then analyze either bacterial sequence or antibiotic resistant gene sequence from that DNA directly from the water sample. This thing we don't call whole genome sequencing, we call metagenomic sequencing, shotgun metagenomic sequencing to be more precise. So that's what we did. So we sampled 76 in 2016, 79 sample around 60 countries around the world that you can see in the yellow dot there. And then we took the wastewater sample, extract DNA, and did sequencing all of them, and quantify and qualify the abundance of antibiotic resistance. So this is the abundance of antibiotic resistance in each of the sample. Each dot represent each of the samples, and then we separate them or group them into different continents. And you can see that the x-axis is different continents, the sample from different continents, and the y-axis is the abundance of antibiotic resistant genes from the sequencing data of the water sample. Okay, so the term FPKM is just normalization approach to normalize the abundance of AMR to be able to compare between samples. Okay, so the higher FPKM, the higher abundance of AMR. The lower abundance of AMR. And you can see that the sample from African continents, South America, and also Asia, they are higher than the sample from European countries or North American countries. So you can do further on, that's only the sum up. You can take the entire profile, the entire abundant profiles of different hundreds of antibiotic resistant genes from each of the sample and put them using PCA, put them into this two-component PCA. So the point is, each dot represents its samples. The closer of the dot, it means the closer of their abundance of AMR gene profiles, okay? And you can see that abundant AMR genes, abundant profiles of this world already divided into Asia, African, South American, European, and North American countries. So there already a divide or separations of abundance of AMR profiles around the world. And then now we know the occurrence of AMR. What about what is the driver? What is the driver that's causing some city having higher abundance of AMR and some city having less abundance of AMR? So we know the data like temperatures, flight connection between cities. We know antibiotic use from different countries, even though it's not really perfect data. And we also use Human Development Index, how well different country develop, score from 1 to 100. 1 is the best, 100 is the least developed, okay? And we put this data together with the AMR abundance from metagenomics result and put them into the regression plot and see if any of these factors could be regressively related or associated with abundance of AMR. It turned out that it's nothing to do about temperature, nothing to do about flight connections, but there is thing to do with antibiotic use, which is fine. We know the more we use antibiotics, the resistant it is, right? But what is interesting us that the Human Development Index has more significant to be associated with abundance of AMR stronger than antibiotic use. That is make us curious about it. And this Human Development Index, it came from thousands of variables data that describe different countries from World Bank. That variable data, for example, how many doctors you have, how many graduate students you have, how many people that die because of this disease you have, how investments in sanitation. So it's like thousands of parameters, variables in different cities. So we actually took that data from the World Bank, which is thousands of variables that describe different cities. And then we use not just the regressions model, we use machine learning model because this is more complicated than a simple regressions. So basically what we use, so you can see each of the row is like each of the sample, the sewage sample, the wastewater sample, and the outcome, you can see them like higher or lower abundance of AMR or the total abundance of AMR. And then each of the columns, you can see them is like the data from World Bank, which is thousands of columns. So machine learning will look through if each of these columns, which is the data from World Bank, can be associated with higher or lower abundance of AMR. And this is what we see. On the left-hand side of yours is the predictor from the World Bank data that related to having higher AMR. On the right-hand side is predictor that predict to be, if you have these predictors, your city or country likely to have lower AMR. Some of them are making sense. For example, if you have high investment in water and sanitation. So basically, if your country or city have access of clean water and sanitation, you have less likely to have AMR. So that's because you probably have less likely to spread of infectious diseases and also bacteria that is a carrier of antibiotic resistant genes. Another thing that machine learning can do is we don't have access to all the water sample from every countries. So, but every country has World Bank data. So we take World Bank data from all the countries in the world and then use machine learning to learn and predict the abundance of AMR. And that's what we did. And we plot them into this map. So the more intense of the color, the higher abundance of AMR. The less intense of the color, the less abundant of AMR. You can read more about this detail in this paper in Nature Communication. And we also That's the data from 2016. We analyzed the data, the sewage data, until 2019, which we just recently published in this paper, which result is pretty much similar to what we found in 2016. Okay, let me move on to the other questions on the epidemiology that you deal with infectious diseases. Has it been seen before? Is it part of the outbreak or not? To answer this, you need to make some kind of dendrogram or a map of all of these bacterial genome to see if it's related or not related. And the map or the dendrogram I talk about, in bioinformatics, we call them phylogeny or phylogenetic tree. So if you don't know what it is, just see them as a dendrogram to see how closely related the bacterial strains. Okay, so this phylogenetic approach is used a lot in the classical taxonomy that classify different species. And now we use it a lot in outbreak detection in the evolution of the bacteria from sequencing data, okay? So how do we do that? There are plenty of different phylogenetic approaches. One of them is called SNPs, or single nucleotide polymorphism. You basically look for a single mutation in the genome, and they use that single mutation to make phylogenetic tree. So how do we do that? So first of all, in order to make a tree from SNPs or single nucleotide polymorphism, you need to identify SNPs. And to identify SNP, you need a reference genome. Let's see this one as a reference genome. And then you have your own bacterial genome, and then you do the alignment. And then you see, okay, now I see there is one single mutation that could be SNPs, okay? So, but SNPs is just a single mutation. How can you make a tree of just a single mutation? You can't. But what you do, you need to concatenate them. For example, I have two genomes. When you build a tree, you need more than two, okay? But it's just example. So this is they map to the same reference genome, and they have the position of reference genome, and then reference genome nucleotide, and the chain, which is the SNP. So you can do concatenate SNP. So take the SNP from each of the genome according to the position of reference. And then you don't have only one single nucleotide. You have an alignment, a strand, as a string of the nucleotide sequence. And that you can start doing multiple alignment and build the tree. And how do